How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're here to do HackerFrogs After School. We're here to do HackerFrogs free hacking. We're hacking all the things. So let's talk about what we're going to be covering today, because we like to cover a bunch of different topics on each one of our live streams. It is, what day is it today? It is Friday, April 17th, and we've got 5 topics to work through. The first topic we're going to be doing is some, we're changing the schedule a little bit. We're going to be learning about AI stuff today because it's something I really want to educate myself on. So we're going to be doing a little bit of research on what AI is, a little bit of an AI course. This is going to be over at Elements of AI. BM B Kim King, hello. Saturday here. Okay, you must be in Europe or Asia, one of the two. But hello, nice to see you here. And yeah, so we're going to be doing some AI research stuff, and then we're going to be doing Advent of Code 2015. We're going to be doing some Python programming, and then we're going to be working into some HackerFrogs AfterSchool Web App Basics. We're doing session number 5 today, and session number 5 is we're going to do a crash course on how to use the SQL query language, and because SQL is essential for learning about SQL injection attacks, which are pretty common on web applications. So it says it's still Friday for me, so I expect Asia. Yeah, Africa. Oh, okay, Africa. No worries. Hello, and Aiden Hall, hello to you too. And yeah, so we're going to be doing HackerFrogs After School. We're going to be learning about SQL, and then we're going to be doing some CSRF Labs over at PortSwigger. CSRF stands for cross-site request forgery, and we're going to be figuring out what that vulnerability is over at PortSwigger. We're going to be doing some labs and educating ourselves. And the last thing we're going to be doing today is we're going to be doing some online store hacking over at the HackSmarter Juice Shop, which is hosted over at HackSmarter. So that's going to be the schedule for today. And without further ado, let's get into the first topic. Select star from users where password equals A or 1 equals 1. So that's everything. Yep. All right, so let's go ahead and put 60 minutes on the clock, and we'll start into our first topic. Just a second. Got to get the timer started now. Okay, and we're doing topic number 1, research on AI with elements of AI. Topic number 2 is going to be in an hour or so, and that's going to be Advent of Code 2015 with Python coding. We're doing SQL later. Yeah, SQL later. Correct. All right, so let's go ahead and start. And while we're doing this, we can put on a little bit of music. Let's do some of this mellow music to get us in the mood. A little bit softer. Okay, and what are we learning today? We're learning over here, over at elementsofai.com. This is a course that you can take yourself for free, and that's my favorite price. And we've come up on chapter 2 of 6, and we're going to be talking about AI problem solving today. So join us if you want to learn a little bit more about AI. I definitely need to educate myself. This is why we're doing this. So search algorithms don't necessarily feel like very cool AI methods. However, they can be used to solve tasks that most of us would admit require intelligent, like navigation or playing, which require intelligence like navigation or playing chess. So search algorithms, huh? Alright, so in chapter 2 we will cover the following sections. Click below to get started, okay? We've got section 1, search and problem solving. We got section 2, problem solving problems with AI. And section 3, search and games. So let's go ahead and start section number 1. Aiden Hall asks, are we doing CTF challenges today? Are we doing CTF challenges today? I think we're going to be doing CTF challenges starting in the 4th hour of today's stream, so most of the warm-up we're not really going to be doing CTF challenges. But we're going to be doing some AI learning right now. So search and problem solving. Many problems can be phrased as search problems, okay? So this requires that we start by formulating the alternative choices and their consequences. So search and practice, getting from A to B. Imagine you're in a foreign city at some address, say a hotel, and want to use public transport to get to another address, a nice restaurant perhaps. What do? If you are like many people, you pull out your smartphone, type in the destination, and start following the instructions. So type in the destination, start following the instructions on your smartphone, okay? So this question belongs to the class of search and planning problems. Similar problems need to be solved by self-driving cars and, perhaps less obviously, AI for playing games. In the game of chess, for example, the difficulty is not so much in getting a piece from A to B as keeping your pieces safe from the opponent. Okay, so SysOS says, look around and see if you can find any. Well, I mean, depends on your circumstances, of course. Okay, so we got a list of different steps to get to your goal. Often there are many different ways to solve the problem, some of which may be more preferable in terms of time, effort, cost, or other criteria. Different search techniques may lead to different solutions. And developing advanced search algorithms is an established research area. Okay, so we could go from 1, 2, 3, 4, 5 to the goal, or go from 1, 2, skip 3 to 4, or you can go from 1 to the goal. So there are many different ways we could solve the same problem. I guess this is what they're trying to illustrate here. We will not focus on the actual search algorithms. Instead, we will emphasize the first stage of the problem-solving process, defining the choices and their consequences, which is often far from trivial and can require careful thinking. We also need to define what our goal is, or in other words, when we can consider the problem solved. After this has been done, we can look for a sequence of actions that leads from the initial state to the goal. In this chapter, we will discuss two kinds of problems: search and planning in static environments with only one agent, or games with two players or two agents who are competing against each other. These categories don't cover all possible real-world scenarios, but they are generic enough to demonstrate the main concepts and techniques. Okay, before we address complex search tasks like navigation or playing chess, let us start from a much simplified model in order to build up our understanding of how we can solve problems by AI. Okay, and we've got, what are these? Oh, okay. So it looks like a problem-solving exercise where you need to ferry animals across to the other side. I think I've seen this kind of problem before. Maybe you have as well. Okay, toy problem, chicken crossing. We'll start from a simple puzzle to illustrate the ideas. A robot on a rowboat needs to move 3 pieces of cargo across a river: a fox, a chicken, and a sack of chicken feed. It's a classic logic puzzle. Yeah, I think I've seen this before. So the fox will eat the chicken if it has the chance, and the chicken will eat the chicken feed if it has the chance, and neither is a desirable outcome. The robot is capable of keeping the animals from doing harm when it is near them, but only the robot can operate the rowboat, and only 2 of the pieces of cargo can fit on the rowboat together with the robot. How can the robot move all of its cargo to the opposite side of the river? Okay, so the easy version of the rowboat puzzle, if you have heard of this riddle before, you might know that it can be solved even with less spaces on the boat. That will be an exercise for you after we solve this easier version together. Okay, let's talk a little bit about this exercise. So, So this is the rowboat puzzle, and we've got 3 pieces of cargo. There is a chicken, a sack of chicken feed, and there's a fox. So the rules are, if the chicken and the fox are together, the fox will eat the chicken. And if the chicken and the chicken feed are together, the chicken will eat the chicken feed. So we can move 2 pieces of cargo in a single trip. So, I mean, I think the easy version of this would involve moving the... moving the fox. We move the fox by itself to the other side. And then... Well, okay, so 1... Move the fox to the other side, and then... Oh, no, we can't move the fox to the other side by itself. So move the fox and the chicken feed to the other side, leaving just the chicken. And then number 2, move the chicken to the other side. And that should solve the puzzle. Well, I mean, I think that's a solution. If you don't think it's a correct solution, let me know in the chat. But anyways, let's read on. So we will model the puzzle by noting that 5 movable things have been identified: the robot, the rowboat, the fox, the chicken, and the chicken feed. In principle, each of the 5 can be on either side of the river, but since only the robot can operate the rowboat, the 2 will always be on the same side. Thus there are 4 things with 2 possible positions for each, which makes for 16 combinations, which we will call states. Okay, states of the chicken crossing puzzle. So let's see. So the first state is everything is on the near side. So the near side, the initial side. And there are all of these other possibilities here for either the robot, the fox, the chicken, or the chicken feed. So we'll just move on down. Okay, we have given short names to the states because otherwise it would be cumbersome to talk about them. Now we can say that the starting state is N, 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 and the goal state is F, 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 F. Instead of something like, in the starting state, the robot is on the near side, the fox is on the near side, the chicken is on the near side, and the chicken feed is also on the near side. And in the goal state, the robot is on the far side, and so on and so on. So some of these states are forbidden by the puzzle conditions. For example, in the state NFFN, meaning that the robot is on the near side, with the chicken feed, but the fox and the chicken are on the far side, the fox will eat the chicken, which we cannot have. So we can rule out the states, these ones over here. Okay? And then we are left with the following 10 states. And we've got the 10 states over here, okay? Next we will figure out which state transitions are possible, meaning simply that as the rowboat rows the boat with some of the items as cargo, what the resulting state is for each case. It's best to draw a diagram of the transitions, and since in any transition the first letter alternates between N and F. It is convenient to draw the states starting with N, so the robot is on the near side, in one row, and the states starting with F in another row. Okay, so we've got all of these states where the robot is on the near side over here, and the rows with all of the robots on the far side on the other row. So let's draw the transitions. We could draw arrows that have a direction so that they point from one node to another, but in this puzzle the transitions are symmetric. If the robot can row from the state NNNN to state NFNFF, it can equally well row the other way from FNFF to NNNN. Thus, it is simpler to draw the transitions simply with lines that don't have a direction. Starting from NNNN, we can go to FNFN, FNFF, FFNF, and FFFN. So from here, all the objects are on the near side. We can go to these possibilities over here. Okay, then we fill in the rest. So there's a big matrix of possibilities. So we have now done quite a bit of work on the puzzle without seeming any closer to the solution. And there's little doubt that you could have solved the whole puzzle already by using your natural intelligence. But for more complex problems, where the number of possible solutions grows into the thousands and in the millions, our systematic or mechanical approach will shine, since the hard part will be suitable for a simple computer to do. Now that we have formulated the alternative states and transitions between them, the rest becomes a mechanical task. Find a path from the initial state NNNN to the final state FFFF. One such path is colored in the following picture. The path proceeds from NNNN to FFFN. The robot takes the fox and the chicken to the other side. Thence the NFNN, the robot takes the chicken back to the starting side, and then finally to FFFF. The robot can now move the chicken and the chicken feed to the other side. Okay, so this was a solution that I didn't think of, because I didn't think that the robot could bring something to the other side and then back to the starting position. But I mean, this is a possibility, so that's great. Okay, state, space, transition, and costs. To formalize a planning problem, we use concepts such as the state space, transitions, and costs. So what is the state space? So the state space means that the state space is the set of possible situations. In the chicken crossing puzzle, the state space consisted of 10 allowed states, NNNN through FFFF, but not, for example, NFFF, which the puzzle rules don't allow. If the task is to navigate from place A to place B, the state space could be the set of locations defined by their XY coordinates that can be reached from the starting point A. Or we could use a constrained set of locations. For example, different street addresses, so that the number of possible states is limited. Okay, and we've got transitions. Transitions are the possible moves between one state and another, such as NNNN and FNFN. It is important to note that we only count direct transitions that can be accomplished with a single action as transitions. A sequence of multiple transitions, for example, from A to C, from C to D, and from D to B, the goal, is a path rather than a transition. And we've got costs. Costs refer to the fact that oftentimes the different transitions aren't all alike. They can differ in ways that make some transitions more preferable or cheaper, in a not necessarily monetary sense of the word, and others more costly. We can express this by associating with each transition a certain cost. If the goal is to minimize the total distance traveled, then a natural cost is the geographical distance between states. Cyberfull, hello, what is up? Nice to see you here on YouTube. We're just talking about some AI stuff right now, and we've got a schedule over at our Reddit. I'll give you the link over here. So if you want to see what kind of stuff we're going to be up to today, you can find it over here. Okay, if the goal is to minimize the total distance traveled, then a natural cost is the geographical distance between the states. On the other hand, the goal could actually be to minimize the time instead of the distance, in which case the natural cost would obviously be the time. If all of the transitions are equal, then we can ignore the costs. Okay, so exercise 5, a smaller rowboat. So in the traditional version of this puzzle, the robot can only fit one thing on the boat with it. The state space is still the same, but fewer transitions are possible. So using the diagram with the possible states below as a starting point, draw the possible transitions in it. It is much easier to do this with a pencil and paper than without. Having drawn the state transition diagram, find the shortest path from NNNN to FFFF and calculate the number of transitions on it. Okay, please type your answer as the number of transitions in the shortest path, just a single number like 12. Do not include any further description of your solution. Hint: do not count the number of states, but rather the number of transitions. For example, the number of transitions in the path NNNN, FF, NF, 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 and FFFF is 3 instead of 4. So we count the number of arrows instead of counting the number of states. Sick in the Mind, hello, nice to see you here. What is up? We're doing a course on AI right now over at elementsofai.com. Here's the link if you want to check it out. We're talking about AI and how it can do problem solving. And we're using the chicken and the rowboat. So you have to ferry across chickens and foxes and stuff, and they can't stay on the same side by themselves, otherwise they destroy each other. And yeah, this is what we're talking about. Okay, so we need to count the number of transitions from these different states. So the number of transitions in this line over here is going to be 3, because there's 3 changes in transitions. So there's 3 transitions. Okay, and what do they want? They want the shortest path from NNNN to FFFF. So I mean, let's think about this. So we want to start with all of the, let's make this bigger. Okay, that's about as big as we can get it. So we want to start with all of the animals on the same side, and we want to end with all the animals on the opposite side over here. But there are conditions that can't that are not allowed. So for example, the fox and the chicken can't be on the same side without the robot, and the chicken and the chicken feed can't be left in the same side without the robot. And we've only got one space on the boat. So the robot can be with any of these objects. Well, let's think about it. So this is the rowboat puzzle again. So now we're doing the rowboat puzzle standard version. So this is the same as the puzzle above, except we can only fit one piece of cargo on the boat. So we can only fit the chicken or the chicken feed or the fox. Okay, so let's think about this. So we start with position or state NNNN. So the chicken, what is the order in here? So the order is robot, fox, chicken, chicken feed. Robot, fox, chicken, chicken feed. The order of the objects is 1, robot, 2, fox, 3, chicken, and 4, chicken feed. So we start with NNNN, and we need to get to N stands for near side and F stands for far side. And we want to attain the state FFFF. So the goal is to attain the FFFF state in the least number of moves. So what's the best way to do this? So let me think about this for a second. So start FFFF, and then we transition to what do we need to move first? So we can't leave. We can't leave the fox with the chicken. So either the fox or the chicken needs to go over. I think we need to move the chicken by itself, because the fox can remain with the chicken feed. So it would go F, no, N, no, we start, sorry, we don't start with FFFF. We start with NNNN, and then we move to robot on the other side, fox on the near side, chicken on the far side, and chicken feed on the near side. So this works because the fox and the chicken feed can be on the same side. So we move the chicken over to the other side, and then we move to robot on the near side, robot on the near side, fox on the near side, chicken on the far side, and chicken feed on the near side. And then we move to... So what can we bring over next? We can bring over so the chicken is on the other side. Next we can do the robot on the far side, and they can bring over the fox. So the fox on the far side, the chicken on the far side, and the chicken feed on the near side. Okay? And we've got an ad running on Twitch right now. So while the ads run on Twitch, we'll also take a little break. I've got a new I've got a new a new bird video. I've got chicken on the brain, but here are the birds. And this is the one where the bird hides the peanuts. Okay, so enjoy this little video. Oh. Oh no, we've got a new one. It's bird time. Yeah, hold on. I've got a better version of this one. Let me pull that up. It's over here. This one. Okay, we'll be back in about 60 seconds while I have a little bit of water, okay? So enjoy the music and enjoy the birds. Okay, so this guy is a Stellar's J. He's shaking the peanuts because he's trying to figure out which is the good peanut. I don't know how he figures out which one is the good peanut, but he's got his methods, and then he flies away to hide the peanut for later. Anyways, let's get back to the logic puzzles that we were doing there. Okay, so we move the chicken feed over. No, we move the chicken over first, and then we come back, and then we move the fox over. We move the fox over, and then after we move the fox over, we move the chicken back with us. So we go robot on the near side, fox on the far side, chicken on the near side, and the chicken feed on the far side. Ask the fox to eat the chicken. So we're trying to do it without getting the... we're not trying to get the stuff, the chicken eaten by the fox. Buster Oda home. Hello, nice to see you here. What is up? Okay, using the same way the squirrels do it in Charlie and the Chocolate Factory, no doubt. I mean, these animals have their methods. Okay, so we move the fox over, and then we move the chicken back. So now the fox and the chicken feed are on the far side, and the robot and the chicken are on the near side. So what's on the near side? Okay. And then from the robot and the chicken come back to the near side. And then we move all of them over to the far side. So F, 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 F. So I think this works. But let's everyone on the near side. And then in the second state, so 1, everyone on the near side, 2, the robot and the chicken on the far side. And then we do everyone but the chicken on the near side. So this, and then we do everything but the chicken feed on the far side. And the last one is everything but the chicken feed on the far side. This doesn't work. Okay, so we do everyone on the near side here, and then we do the robot and the chicken feed on the far side. This works because there's no conflicts. And then we do number 3. This one is... oh, actually this works. So number 3 is everything but the chicken feed, everything but the chicken on the near side. Okay, and then number 4, everything but the chicken feed on the far side. This works because the robot is there, and the robot prevents the fox from eating the chicken. And then number 5, 2, 3, 4, 5, is the robot on the chicken on the near side. Okay, and the last one is everyone on the far side. So how many transitions is this? So this is 1, 2, 3, 4, 5 transitions. Thank you very much for following on Twitch. 4x4 Fan Taridoni. Thank you very much. Okay, and that's a Santa emote. What is that? Holiday Santa. Thank you very much. Alright, so it looks like the number of transitions is 1, 2, 3, 4, 5. So we'll use that as the answer. Answer is 5. Submit. Your answer is not correct. Oh. Darn it. This but Santa. Yeah. Okay, the correct answer is 7. There are 2 short paths that lead from the start, NNNN to the goal, NNF. One of them is NNNN, F and FN. Okay, move one thing over. And then NNFN, come back. And then move another thing to the far side. So this has to be either the fox or the chicken feed. Intuitively, the strategy is to move the chicken over the other side first, then go back to get either the fox or the feed, and then take it to the other side too. Then the robot takes the chicken back to the near side to save it from being eaten or eating the feed, and then takes the remaining object, the fox or the feed, from the near side to the far side. Finally, the robot goes to fetch the chicken and takes it to the other side to reach the goal. So I missed a step here. That's unfortunate. Let's see if we can do better on this next exercise. So the next exercise is Santa better than, what is that thing? Is this basically a word version of the Hanoi Tower? I mean, I think the second exercise we're going to try to figure out is the Hanoi Tower. I've never encountered this before, so I just said it. NASA Sparkle. NASA Sparkle but Santa. Okay. Stoic Booty. Hey, what is that chicken? There's a chicken there. That is a Skinba 1? I don't know this channel. It's a kids ring game. Oh, yeah, right. I think I see it featured in a lot of video games. Okay, so let's do another puzzle, the well-known Towers of Hanoi. In our version, the puzzle involves 3 pegs and 2 discs, 1 large and 1 small. Actually, there can be any number of discs, but for the exercise, 2 is enough to demonstrate the principle. In the initial state, both discs are stacked in the first leftmost peg. The goal is to move the disc to the 3rd peg. You can move 1 disc at a time from any peg to another as long as there is no other disc on top of it. It is not allowed to put a larger disc on top of a smaller disc. But now with auto rewrite. How did I know that exercise was leading up to this? Well, I mean, I'm not too sure. Maybe it's a very well-known kind of thing. Anyways, my music has stopped, so I'm just going to put on some new music just a second. Let's go with some Dungeon of the Endless. Classic logic training for CS. Yeah, I mean, I guess you would use these kind of exercises for AI as well. My SQL map is taking its sweet time. Oh, is it? What kind of exercise are you doing right now? Sick in the mind? Okay, so the picture shows the initial state and the goal state. There are also 7 other states, so that the total number of possible states is 9. 3 ways to place the large disk, and for each of them, 3 ways to place the small disk. So the goal state, the initial state is 1 disk on, well, smaller disk on top, larger disk on the bottom, and the goal state is to get them over to the third tower. Oh, just as HTB box, okay. So your task, draw the state diagram. The diagram should include all the 9 possible states in the game, connected by lines to show the possible transitions. The picture below shows the overall structure of the state diagram and the positions of the first 3 states. It shows that from a starting state at the top corner, you can move to the other 2 states, the 2 other states by moving the small disk. Complete the state diagram by placing the remaining states in the correct places. Note that the transitions are again symmetric, and you can also move sideways left or right or up in the diagram. After solving the task using pen and paper, enter your solution by choosing which state belongs to which node in the diagram. Hint: each state belongs to exactly 1 node. Okay, so what do we got here? So apparently there are 9 states in this game, and we're supposed to fill in possible states to finish them. I mean, I'm guessing that Let's think about this. Oh, time-based blind SQL injection. Yeah, that's the worst. You definitely don't want to do that manually. IHH. Hello, nice to see you here. What is up? So we're talking about the states of our Towers of Hanoi game. I mean, we can talk about this one too. Okay, so in this game, we start with a small disk on top of a large disk, stacked on a tower on the left-hand side. The goal of the game is to move the disks one at a time to achieve a state where the large disk, where the small disk is stacked on the large disk on the tower on the right-hand side. Okay, it wouldn't be so bad if it wasn't 19 tables in the database. That sounds like not a lot of fun. But yeah, it's a good thing we've got tools like SQL map so that we don't have to do this manually. So we can define the states of the game in the following way. So the first state is, I mean, how would we, so I guess left, middle, right, and we would do small disk on the bottom, large disk on the small disk on the top, large disk on the bottom, and in the middle there's nothing there. And I guess the state we want to achieve is left nothing, middle nothing, right small disk on top of large disk, like this. So they want us to map out the 9 states of the game. So this is the first state, and then the second state is this, and the third state is the large. Okay. So let's map this out. So we would go from LDDMR. I guess we can put this in between some parentheses to make it nice and encapsulated. Then we move to LDMDR, like this. And then we move to LDMRD, like this. So this is the first 3 states of the game, according to the diagram here. Then we would do, and I guess the next thing that we would do from here is we could map out After solving the task using pen and paper, enter a solution by choosing which state belongs to which node in the diagram. Which state? Okay, choose one for each node 1 to 6 in the above diagram for the correct state A to F from below. What state should be in box 1? What state should be in box 1? Okay, so let's map this out ourselves. So from this state, what would the next state be to solve the game? So the game is solved in either node number 3 or node number 5, I'm guessing, or is there only one way to do it? Okay, so let's pretend we're just trying to do it like, we're trying to solve the problem as soon as possible. So the next thing we would do is we would move the large disk to the middle. So they would do L, M, D, R, small d. And then we would move the small disk on top. So it would be L, M, D, D, R, like that. And then we would move the small disk over to the left-hand side. So it would be L, D, M, capital D, R. And then we would transition to L, small d, M with nothing, and then R with the large disk. And then we would move the small disk on top over to the right side. Well, first to the middle and then to the right side to finish the game. So it's L, M, D, R, D. And the final state is left with nothing, middle with nothing, and then R with the small disk on top of the large disk, like that. Okay, Stoic Booty says purple on bottom at far left. Yeah, purple. So what we need to do is we need to move from here to the large disk in the middle, and then move the small disk on top, and then over to the left, so that we can move the disk from the middle over to the right. And then we move the small disk, which was over here, over to the middle, and then over to the right to finish the game. You make me want to go study. I don't know if I want to take that. Is that a compliment or is that not a compliment? I mean, we're talking about these logic problems. So from here, it would go. I mean, number 1 has to be. Okay, let's map this out. So there's 1, 4, 2, 3, 1, 4, 2, 3, 5, 6. 1, 4, 2, 3, 5, and 6. So 1 has to be well, basically this. So, I mean, the large disk can't go on top of the small disk. Am I misunderstanding something here? So, this has to go here. So this is left, right. One has to be left, middle, right. And it's going to be large one and on the left and small one on the right. Large can go on the right. Oh, wait, I was under the assumption that we could only move one at a time. Okay, 100% compliment. Love the way you manage stuff with the Nano, and genuinely love like your streams. You chill. Thank you very much. So I guess, yeah, that's true. They didn't. I for some reason I made the assumption that you can't move this over to the left-hand side in one go. I thought you needed to move from the middle over to the end. Okay, you can move 2 steps at a time, so you can go straight from left to right. Okay, okay. So this was something I was understanding. Okay, so that means that this would probably go to small one in the middle and then large one on the left. Small one in the middle and then large one on the right, rather. Okay, so this was small one in the middle and then large one on the left. Okay, and then state number 4 would be... State number 4 would be large one in the middle and then small one on the right. Left, middle, right. Small one in the middle. No, what was it? Large one in the middle, small one on the right. Like this. Okay, and I mean, they all start off looking like this, so let me just set this up. Okay, so we just need to figure out the other 4 states, and then we'll be good. Must be because the rightmost picture on the second line also does that. The rightmost... okay. Okay, okay. So, so number 4 has to be... yeah, so we just did number 4. So, if we assume that the large one... which one are we dealing with next? So we're dealing with either 2 or 3. 2 or 3. So from 1, we do 2 or 3. So if 1 is large one, small one in the middle, large one on the right, then we go, oh, this is the finish, the end state. So the end state is small one stacked on top of the large one here. That's number 2. And the other one from here would be small one on the left and large one on the right. Yeah. So small one on the left, large one on the right. So that's 2 and 3. And then we've got 5 and 6 to worry about that that come off of 4, well, number 4. So number 4 is large one in the middle, small one on the right. So large one in the middle, small one on the right would go either large one in the middle, small one on the left, or small one stacked on top of the large one in the middle. So either one of these. Okay, so let's take a look at the diagram. And for each node 1 to 6 in the above diagram, the correct state A to F from below. For each node in the above diagram, choose for each node the correct state. Okay. So box 1 should be, according to us, it should be large one on the right and small one in the middle. Large one on the right and small one in the middle. So this is E. So state E. Okay, what state should be in box 2? Box 2 is down here. And box 2, according to us, is stacked. Stacked on the right. So stacked on the right is B. So this is state B. So box 3, according to us and what we were looking at, was small one on the left. Small on the left, large on the right. Small on the left, large on the right is state F. So this is state F. And what should be in box 4? Box 4 is large in the middle, small on the right. Large in the middle, small on the right, this is state D. Okay, and what should be in box 5? Box 5 should be small on the left, large in the middle. Small on the left, large in the middle, so this is state C. And box 6 is both stacked in the middle. Both stacked in the middle, which is state A. Okay, let's see if we got that right. 6 answers correct. Okay, I managed to... I am not good at logic puzzles, so it's always a bit nerve-wracking for me every time I do something like this. Okay, so we'll move on to the next section. So solving problems with AI. It seems like we weren't solving problems with AI, we were solving problems ourselves. But anyways. So interlude in the history of AI starting from search. AI is arguably as old as computer science. Long before we had computers, people thought of the possibility of automatic reasoning and intelligence. As we already mentioned in Chapter 1, one of the great thinkers who considered this question was Alan Turing. In addition to the Turing test, his contributions to AI and more generally to computer science include the insight that anything can be computed. Solving them often builds more confidence. I mean, if you've done these kind of questions over and over again, it's impossible not to get better at these problems. Anyways, we've got ads going on Twitch right now. So when the ads happen on Twitch, we put on the birds. How about these birds? Okay, so we'll be back in about 50 seconds. Enjoy the birds and the music. I'm going to have a little bit of water. Have some water too, no worries. Yeah, everybody, if you need to get up and get some water, go use the washroom, it's a good time to do that. Let's put the birds away, and we'll get back to the hacking. Let's see. Didn't Babbage already think of such possibilities together with Ada? I'm not too sure about that history there. So, let's see. So anything can be computed. That means calculated either using numbers or other symbols, and it can be automated. So helping to win World War II, Turing designed a very simple device that can compute anything that is computable. His device is known as the Turing machine. Hanzo League, hello, nice to see you here. While it is a theoretical model that isn't practically useful, it led Turing to the invention of programmable computers, computers that can be used to carry out different tasks depending on what they were programmed to do. So instead of having to build a different device for each task, we use the same computer for many tasks. This is the idea of programming. Today, this invention sounds trivial, but in Turing's days, it was far from it. Some of the early programmable computers were used during World War II to crack German secret codes, a project where Turing was also personally involved. So the term artificial intelligence was coined by John McCarthy, who is often referred to as the father of AI. This term became established when it was chosen as the topic of a summer seminar known as the Dartmouth Conference, which is organized by McCarthy and others in 1956 at Dartmouth College in New Hampshire. So CSOS says Turing proved that we do not need dedicated machines, but can make generic programmable machines to do calculations. Yeah, I mean, I guess this is what we're talking about when we're talking about AI as well, because we like to think that eventually we could develop something that could solve all different problems, and that is called like AGI, versus what we have right now, which is what is it called? Like specific artificial intelligence. I had a list of these definitions over here. Hold on, let me get them. Tech literacy, AI notes. So narrow AI. So what we have right now is narrow AI that handles certain tasks. And what we want to eventually get to is general AI that can handle any intellectual task. Specific or narrow AI? Yeah. Specific or narrow AI versus general AI. Okay, so the proposal contains the following crucial statement. We're a long way from AGI. Maybe one day. McCarthy's key statement about AI, the study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be precisely described, then a machine can be made to simulate it. So in other words, any element of intelligence can be broken down into small steps, so that each of the steps is as such so simple and mechanical that it can be written down as a computer program. This statement was, and is still today, a conjecture, which means that we can't really prove it to be true. Nevertheless, the idea is so absolutely fundamental when it comes to the way we think about AI. For example, it shows that McCarthy wanted to bypass any arguments in the spirit of Searle's Chinese room. Intelligence is intelligence, even if the system that implements it is just a computer that mechanically follows a program. So why search and games became central in AI research? As computers developed to the level where it was feasible to experiment with practical AI algorithms in the 1950s, the most distinct AI problems, besides cracking Nazi codes, were games. Okay? CSOS says, if it's false, AGI might be possible or not be possible for all problems. Games provide a convenient restricted domain that could be formalized easily. Board games such as checkers, chess, and recently quite prominently, Go, an extremely complex strategy board game originating from China at least 2,500 years ago, have inspired countless researchers and continue to do so. Closely related to games, search and planning techniques were an area where AI led to great advances in the 1960s. Algorithms with such names as the Minimax algorithm or alpha-beta pruning, which were developed then, are still the basis for game-playing AI. Although, of course, more advanced variants have been proposed over the years, in this chapter we will study games and planning problems on the conceptual level. I hate AI. I hate AI. Well, I mean, it's pretty much impossible to avoid AI these days, IIHH, so it's kind of a hard position to be in a society that embraces AI and uses AI every day if you hate AI. Okay, so the next section is search and games. We're going to have to come back to this later. because we've run out of time and we allotted about an hour to this topic. But we'll be back next time, and we're going to be talking more about AI and trying to work through this course. Yeah, it makes me hate it more. I mean, we learned earlier that there's a lot of AI is basically everywhere these days, and you can't do any computing. You can hardly do any computing without some sort of AI algorithm involved. So it's tough. Anyways, we'll move on to the next topic. So topic 1 is done. We're going to be doing some programming now. So topic 2 is programming, and topic number 3 is going to be web app stuff. So let's go ahead and put 60 minutes more on the clock. And yeah, if you want to take this course yourself, then you can do it over at elementsofai.com. It's totally free, and if you want to learn more about AI, because everybody's talking about it, it's probably a good idea to educate yourself. Anyways, we're done with this for today, and let's move on to programming. So what we're doing is we're doing some programming challenges from Advent of Code 2015. So this is like a Christmas event, but of course you can do the actual challenges any time of the year that you want to. So we've moved up to day number 8 for Advent of Code 2015, and let's read about what's going on in this challenge. So this is day 8 matchsticks. Space on the sleigh is limited this year, and so Santa will be bringing his list as a digital copy. He needs to know how much space it will take up when stored. It is common in many programming languages to provide a way to escape special characters in the strings. So for example, C, JavaScript, Perl, Python, and even PHP handle special characters in very similar ways. However, it is important to realize the difference between the number of characters in the code representation of the string literal and the number of characters in the in-memory string itself. Okay, so we've got some examples. So empty string is 2 characters of code, the 2 double quotes, but the string contains 0 characters. So this string here, ABC, is 5 characters of code, but 3 characters in the string data. And we've got this example over here with AAA and AAA, but separated with an escape character for the double quote here. So this is 10 characters of code, but the string itself contains 6 A characters and a single escaped quote character, for a total of 7 characters in the string data. And we've got what? We've got an escaped hex code, so /x27. This is 6 characters of code, but the string itself contains just 1, an apostrophe, which is escaped using hexadecimal notation. Santa's list is a file that contains many double-quoted string literals, 1 on each line. The only escape sequences used are \\\, which represents a single backslash, and \double quote, which represents a lone double quote character, and \x plus 2 hexadecimal characters, which represents a single character within that ASCII code. Disregarding the white space in the file, what is the number of characters of code for string literals minus the number of characters in memory for the values of the strings in total for the entire file? So for example, given the 4 strings above, the total number of characters of string code are 23 minus the total number of characters in memory for the string values, which is 11, which is 23 minus 11 equals 12. So in this case, the answer would be 12. Alright, so to begin this, we need to get our puzzle input, which is just a bunch of strings. So this is what our string input looks like here. It's just a bunch of strings that we need to process with our Python program. Okay, so what we're going to do is we're going to set this up. We're going to set up a little coding environment over here. It's nothing very fancy. It's just a nano text editor and then another terminal over here for running the Python code. So to start with, I'm going to grab some code from a previous day, and then we can start from there. Just a second, everybody. So this would be in my walkthrough for Advent of Code for 2015. Let's just grab something from day 1. So what we want to do is we want to get our raw input. So I'm just going to grab this code over here. We're just going to input it over here. So file path equals input.txt. So this is going to be the separate input file. And then with open as file, raw input equals file.readlines. And what we're going to do is we're just going to figure out what is in those, what is in the raw input. And then we're going to work in from there. So we've got our Python code here, and we'll run Python AOC 2015 day 8 part 1, and it looks like this is a list. So this is a list with all of the different lines, and inside each one of these list items we've got a string. So the string is You know, the funny thing is that this is a string inside of a string. I mean, this should be okay, but I guess what we want to do first is we want to recreate the list, but we want to get rid of these new line characters here, because the new line characters are going to interfere with our input. They're going to interfere with our data processing later. So what we need to do is we need to create something called our format list, or formatted input. So we'll call it format input, and we'll define this as an empty list. And then we're going to write a little for loop to create our formatted input. So it's going to be for I in raw input, for I in raw input, we need to do something. We need to format input dot append. We're just going to put in whatever was in the list, but not the entire string. So each I in raw input is going to be one of these strings, either this string or this string or this other string. They're all strings. What we need to do is we need to repopulate the list, but we need to make sure that this new line is clipped off. So I think the method we want to use is called strip. So I.strip. So that'll get rid of any white space characters or new lines. And after we do that, we're going to print the formatted list, print format list, and see if it appears correctly. Okay. Oops. Format list is not defined. Do you mean format input? Oh, okay. It should be format input. Okay. That was a typo. So it looks like it worked. So all of the new line characters have been stripped out. So I guess our actual program is going to start over here. So the program has to do a certain number of things. In this program, we need to process all of the strings in the input.txt file and keep track of two metrics. So So the two metrics are 1, the amount of characters in all of the strings, and number 2, Segfaults, hello. Segfaults, hello. Nice to see you here. What is up? Okay, and we're just doing some programming stuff over here. Ooh, why is it so big? If you want to do the same thing yourself, this is it over here. So the number of characters of code for string literals minus the number of characters in memory for the values of the strings. The number of characters in memory for the values of the strings. So in this case, the number of characters for the string literals is measured over here. So there's 10 characters here, 2 characters in this entire string, 5 characters in this entire string. Characters of code for string literals. So the first thing we need to do is keep track of the amount of characters in all the strings, and the second thing we need to keep track of is the number of characters in memory. So in memory. So I guess we can do a little example here as well. For example, quote is 2 characters in the string, but 0 characters in the memory, because there's no there's nothing that's kept track of in the memory here, but the characters in the string are 2 quote characters. So that's what the program needs to do. At the end of the program, we need to subtract the amount of characters in memory from the amount of characters in the strings. So I guess what we need to do is we need to make sure that we're talking about these things in the correct way. So total characters. So I guess there would be total characters for number 1, and memory characters for the second thing. So I guess we can define these down here. So total characters equals 0, because we're going to be keeping track of this as in the form of an integer. So total characters is 0, and total memory characters in memory is going to be 0 as well. So I guess we can make this a little bit more compact as well. We'll just call this total car and total mem as 2 things that we're keeping track of. So keeping track of the total characters shouldn't be too difficult. If we take a look at the examples here, and you know what, before we get started, I think what we need to do is we need to start a little write-up for this, because we're trying to document everything that we do so that we can come back to these exercises later. It'd be cool to see you try this in another language someday. AKC, hello, nice to see you here. Me too. I'd love to be able to do this in another language. Unfortunately, the only language I feel I'm confident enough to do this in right now is Python, but maybe later if I could do this in like another language, like C or Java or JavaScript or something else. Okay, so we're going to be doing this day 08, part 1. Okay, so we're going to be keeping track of a few different things. AKC says, hi, how are you? I'm doing all right. I'm doing a Friday stream. It is a lovely day outside, and I hope everybody's having a good day. So the URL for the challenge, the concept we need to do to understand the challenge, the instructions that we received with the challenge, and the code we used to solve the challenge. So the URL is over here. Just need to record these things. The concept for this is keeping track of string length versus keeping track of string memory. Okay, and the instructions, I can just grab the instructions and paste them in. Easy peasy. Okay, for the code, I mean, we're not finished, but let's go ahead and try to write as much as we can in the next 44 minutes. We should be able to finish this program in the next 44 minutes, but I guess we'll see what happens. So the total characters and total memory, these are the two variables we need to track to get the answer at the end of the program. Okay, so the first thing we're going to do is, do we need to write a function to do this? So let's do some commentary. So there are three. There are three possible character escapes in the strings. There's one // which is a backslash character. Okay, there is backslash double quote, which is a double quote character. And there is \x, which is a, what is it? Hexadecimal code for an ASCII character. So these are the three things. I mean, I guess. So these are the escape sequences. I'm not too sure what kind of special rules we need to define for these, but I'm sure we're gonna figure it out as we write the program. Okay, so the easiest thing to do is to make a pass for I in, what did we call it again? Format input. So we'll run a for loop again, and we're going to get the length of the string. So length of I plus, we're going to add the length of I to our total characters. So total characters are pretty easy to keep track of. Okay, and then we'll try running this. Ooh, it doesn't like the escape characters along with our quote. Can we put these between some parentheses to get around this? Or is that not going to be a feasible solution? Actually, you know what? Maybe we can just do it like this. We can just put it between some regular quotes like this. Or is it still going to give us the same problem? You need to escape the escape characters. Oh man. I mean, this escape character doesn't need to be escaped. Okay, let's see if this works. It'll probably give us the same problem. No, it doesn't. Okay, it works. It just doesn't like it when it's put between the extended quotes with the triple single quotes. And Ripek, hello, nice to see you here. What is up? Hope you're having a good time, and hope you're having a good day. So, yeah, so I think we got the right number of total characters, because we ran our little for loop to get the length of these things and add it to the total character number. On the strings, it messes up. Yeah. So the next thing we need to do is we just need to calculate. So the total characters, that's fine. The next thing we need to do is we just need to calculate the total in-memory characters. I guess what we could do here, I wonder if there's I mean, there's a lot of string methods. I guess we need to convert these first. Okay, let's grab an example. So we'll grab an example with this over here. What the heck? This is kind of crazy. Hold on. So this is an example of one of the strings. So between the single quotes, I mean, if we put this between some double quotes, it becomes normal again, but... So escape. So this is... Oh, that's funny. So this should be interpreted as a single backslash. Those are escaped characters. Escaped characters. So this should be a single backslash. This should be a single backslash. This should be... What is this? Why are there 4 backslashes? Because you printed them. Let me just grab this. If I try to print it out, what happens? This will probably error out. Okay, we'll try running the program. Let's see, unexpected character after line continuation character. Line continuation character. So it doesn't like this. I probably need to put this between some single quotes. So if we put this between single quotes and try again, what prints out? So what gets removed? So this escapes so that we can put in the backslash. So this is a single backslash, and then this is also a single backslash here. And then this becomes a single backslash, and then this becomes 2 backslashes. So do we try to print these out? How do we handle these? Because we got so many of these. Okay, let me... Those only show when printed, as far as I know. Those only show when you printed. These only show when printed. We have to do it between these. The double escapes. I mean, if we do this between... If we just get rid of the double quotes at the end, is this going to look the same? Yeah, it looks the same. If you actually read the string, they aren't there. If you actually read the string, they aren't there. I mean, when we print it out, the escape characters disappear. Character by character. The escaped, So for each escape character, we need to subtract, like a number. For each one of these lines, we also have to subtract a number. Because whatever appears in memory, so for example, this line over here, the number of characters that actually appear in the memory is going to be the length of the string minus 2. Panako Panko has just raided with the party of 17. Hello, Panako Panko raiders. Kusarigama Muro. Hello, nice to see you here. Crocodile Sand. Hello, nice to see you here. My name is the Shy Hat, and I do cybersecurity stuff on Twitch and on YouTube. Let's give a shout out to Panako Panko. She does hacking stuff, and she also does 3D modeling stuff. If you're interested in 3D modeling or hacking or VTubers, please check her out. It's a great channel. But welcome in, Raiders. We're currently doing some coding exercises over at Advent of Code over here. If you want to join in. Okay. So what we're doing is we're trying to figure out two different sums. We've got a bunch of strings over here, and we need to calculate the number of characters total that are in the string, which is pretty easy to do. The other thing we need to do is we need to calculate the number of characters in memory. So in memory, we need to disregard the double quotes over here, and we also need to disregard the character escapes. So \\/ becomes 1 backslash. So you can do -4 for every /x and -2 for every slash. -2 for every slash. Is it -2 for every slash or -1 for every slash? Because we've got 3 possibilities. So \\/ is actually 1 in the memory, because the escape character itself has to be removed. \\ double quote is just the double quote, which goes in the memory, but the \\, we need to remove this. So it's -1 for every standard escape character, but for the escape characters with the hexadecimal, we need to get rid of more. It is -2. It's kind of a regex. It is kind of a regex, isn't it? But yeah, let me go ahead and put on some new music, and then we can continue with this. All right, let's put on some XCOM 2 music. Actually, you know what I wanted? You know what I want to listen to? I want to listen to some Mass Effect 2 music. Here you go. Okay, so simply you substitute the escape sequence with the character. You substitute the escape sequence with the character, and then do a single pass over the string. I mean, You substitute the escape sequence with the character and then do a single pass. The other thing is that we're supposed to calculate these, but also remove the number in memory for these double quotes. So the double quotes are here, but we need to compensate for the fact that we don't count them in memory. Stoic Booty, hello, what is that? Is that a chicken? Is that a roast chicken? That is a dancing roast chicken. Yes. Okay, so let's see. Double escaped backslash is equals 1 backslash, and 1 backslash equals, and backslash double quote equals just double quote. Roast chicken dancing to Mass Effect. Yeah, okay, no worries. I mean, we could do it like a number of different ways. We could substitute in the character that's supposed to be there, or we could just substitute in the character that's supposed to be there. I mean, if we wanted to do it, we could reduce the length of the string for the escaped characters. You just .decode string escape the thing and call it a day. .decode string escape. .decode. Alright, I mean, what would that... Let me think about what that would look like. So, I mean, if we've got the string, like the string methods, we might as well use the string methods, right? So string print so our test string. So this is our test string over here, and it's going to be this thing, right? Modified string is going to be test string dot decode, and we'll try printing that out. So print modified string. Oops. Do you mean encode? Is it supposed to be encode? Okay. So I mean, when we encode, we turn into bytes. I don't necessarily know if we want to turn into bytes. Test string shouldn't be double encoded. Shouldn't be double encoded. So for each one of these, so this would be escaped. This is just a single backslash. This is also another single backslash. This is another single backslash. No. Yeah. Hold on. If we use double quotes here, it changes. Or does it? Hold on. Let's print out the test string. Test string. Yeah, this doesn't work because it's not escaped properly. Unexpected character after line continuation character. So this has to be put between some quotes again, otherwise this doesn't work. So we want to escape these. I guess the one major thing that's getting in the way here is that they insist on everything being put between these double quotes. That's why they have to escape. Oh, never mind. So if the quotes on the end over here, so the quotes that encapsulate the string, were single quotes instead, it would be a lot easier for us. Okay, I mean, let's think about it this way. If we've got like this kind of sequence here, so \x 40, what is it? 41. So we would expect what's printed here to be the character A, right? So encoded string equals this, and if we print it out, we get the A character. I mean, that's fine. The other thing that we need to think about is what actually happens if we run length on this. So run length of encoded string. Yeah, this is also 1. So despite the fact that there are this number of characters in the string, it still comes out as, oh, you know what? I think for I in format input, total character plus equals length of I. So length of I is each one of these strings. I think the number we get is inaccurate, because the length is going to be after the characters are encoded, or after the escape characters are all escaped and the characters are encoded. So let's think about this. So encoded string equals, so A, B, C, and then the encoding, and then D, E, F, right? If we're to run this, total characters equals plus equals length of A, length of I, then it would be 6 plus 6 plus 1. So this should be 7 right now. So if we run it, yeah, this comes out as 7. So what we're doing here is we're not actually getting the total characters. We're getting the total in the memory. Or at least I think it is. Okay. So let's just quote this out for right now. So this gets quoted out. And we can do, so total characters plus equals the length of format input first element. So first element, element 0. And we'll see, actually wait. Let's take a look at what that element is first. But hey, anybody who's still watching from Panako Panko's stream, what was Panako Panko getting up to? I know that she was doing some modeling earlier, but what were you all talking about on stream? You all talk about some really funny stuff sometimes. So let's see. So this is normal. Actually, let's just see if this is what is actually coming out. I want to see what the total should be. Because we see here 1, 2, 3, 4, 5, 6, 7 characters. Does this count as 7, or does this count as 9? Does this count as 7, or does this count as 9? I really want to figure that out. So print total characters after this. What vulnerability are you exploiting right now? We're not really doing any, we're we're not really doing any hacking right now. We're trying to get better at coding, which is one of these skills that you want to develop when you're trying to become a hacker, or a cybersecurity person, or a tech person in general. But hello, Will. Nice to see you here. What is up? Okay, so this comes out as 9. So this isn't the actual length of the string, because we're not supposed to, actually this is supposed to be 9. Yeah, that's supposed to be 9. Okay, so that is accurate. That does get us the total. It's kind of messed up though. If we take a look at the input here, let's try this for the last element. So we'll do the experiment here, but for element -1, and then we'll see what the length is supposed to be. So what is my guess? My guess is it's going to be what is this even? That's, Okay, so format input. Let's print it out as well. So print it out. Format input element -1. Okay, so this is what prints out. And it says it's 28 characters. So, I mean, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8. So it counts it after the escape characters are escaped. So after the escape characters are all escaped, we can subtract 2 from each one of these strings. Because we're supposed to omit the double quotes over here. Okay, so if we wanted to figure out the total characters, in this case we're not actually figuring out the total characters, we're figuring out the total in-memory characters, because the in-memory characters are after all of the escape characters are escaped. So in this case, calculate the total in-memory characters, and that would be this thing over here. So for I in format input, total, did we call it total memory? Yeah, total memory. Total mem over here. So total mem equals length of I minus 2. Why are we subtracting 2? We have to subtract 2 because we need to omit these 2 characters here. So I mean that should be fine, and then to get the other one, calculate the total characters for I in format input. For I in total input, this is the line. This is the line. For each one of these lines, we want to So for each one of these lines, we need to count each one of the characters in the list. each one of the characters in the string. So for I in format input, for J in I, so this goes down to the characters themselves. And I guess we can keep track of something called all characters. All characters equals 0. Okay, I guess all characters would take up. Well, we'll call this like an empty list. I think you mix them up. I think, I think I am a little bit mixed up, but I think I can get back to in the end. So all characters equals the empty list. For I and J, for J and I, append all characters dot append append J, and then at the end of this, total characters plus equals the length of the all characters list. I don't know if this is going to work, but, well, we'll give it a try. So let's get rid of everything here, and then we'll see what the two values are at the end of all this. So print total character and total memory, total mem. I don't know if it's allowed, but take a look if you want. What is this? Online Python? Oh, yeah. You've got your own solution here. I'll take a look at your solution in a bit. I just want to see if my solution works first. Okay, so we'll print with an F string, something something. So total characters, total mem. Total characters, this, and then do a new line. Total memory. Okay. Silva Vipiridae. Hello, nice to see you here. What is up? I saw you in Panacopanco's chat earlier. Could you tell me what you were getting up to on the stream? What were you talking about over there? Let me know, thank you. Okay. Run Python. Total characters equals 6165 and total memory equals 5595. So I think we might get the correct answer here. So the last thing we need to do is print the answer we want is the answer equals total characters minus total memory. Okay, and we'll see if this works. Maybe? Sorry, what were we talking about? Silva, what are we talking about? Okay, the answer we want is 600. So we'll try answering the question for the day with 600. We'll see if this works. Submit. That's not the right answer. The answer is too low. So this answer is too low. If you're stuck, make sure you're using the full input data. There are also some general tips on the About page. You can ask for hints on the subreddit. So why isn't this working? Okay, and we'll try using the code provided by repec. Okay, we'll save this out. Nano repec.py. Okay. And before we run it, let's take a look at what that code is first. So test string equals this thing over here. X equals length of the test string. X2 equals length of the test string dot encode Unicode escape. Dot encode Unicode escape. Huh. I didn't know that this was a thing. That doesn't read from the file, it's just an example. Yeah, I think I understand that. So print test string. So the test string is this. And then we print X, which is the length of the test string. And then we print out the length of test string.encode Unicode escape. Okay. So let's try running that over here. We need to program an AI. We need to program an AI to figure it out. I mean, we don't need to program an AI to figure it out. We need to figure it out ourselves because that's the exercise. Okay, so we print out the thing literally. So we managed to escape. What did we escape? So we escaped. This became a single backslash. This becomes a single backslash. And then we got our double quote here. And this should be 4 backslashes, 5 backslashes. This is 5 backslashes. Okay, forgot about the about this thing. Yeah, this thing. Let's go back in. So I think that for the total memory over here, we're getting the length of all the items, but we're subtracting 2. We subtract 2 because we're not supposed to include the double quotes. So for each one of these items, there are double quotes here. We need to subtract that from the length. Getting the total characters versus the in-memory characters. So the in-memory characters just cares about what actually prints out. But I don't know. I'm kind of... The length does calculate correctly when we run the length function over a string. I might have an issue here, Repec. It says Repec. Oh, what's the issue then? Okay, we're going to take a little break and watch the birds while we have a little water break. But here are... Here's a squirrel, and we'll be back in about 45 seconds. Oh, I was muted. Sorry, everybody. Thank you very much for letting me know that I was muted. Okay, so right now what we're doing is we're doing HackerFrogs AfterSchool. It's a course that I designed for teaching teaching cybersecurity and hacking basics across a bunch of different categories. Okay, so today we're doing session number 5, and we're going to be learning SQL. Intro to SQL with SQL Murder Mystery. So, Epic muted, not gonna lie. Yep, pretty cool muted. Thank you very much, Polly, for subscribing on YouTube. Thank you. This is the 5th workshop for Intro to Web App Hacking. Let's take a few moments to review the concepts we learned in the previous workshop. We learned about OS command injection. OS command injection, that is operating system command injection, is a web app vulnerability where arbitrary OS commands can be performed on the web server through a web interface. So this is one of the most prized web exploits. If you're able to get OS command injection on a server, that's a really bad thing for the owners of the server. Okay, what did I miss? Well, I mean, we kind of ran out of time on our programming exercise, and we moved on to HackerFrogs AfterSchool web app stuff. So OS command injection can often lead to complete compromise of the web server, and if so, the server can be used as a foothold to attack other machines in the network. So we learned about that last time. If you wanted to watch the session from last time, and where we covered this, you can go back to the stream from Wednesday and go about 2 hours in. And now on to our topic. So the thing we're going to be talking about in today's workshop is we're going to be talking about the SQL database language. So when people talk about SQL, what is this thing? SQL stands for Structured Query Language, and it's a programming language used for managing data held in relational databases. Polly's asked, do you recommend TryHackMe? Yeah, I definitely recommend TryHackMe. If you want to get into cybersecurity, I've got a little guide over here, Get Into Cyber. And it talks about all the stuff that you might want to take a look at and do research on before getting into cybersecurity. But do I recommend TryHackMe for beginners? There's a lot of good stuff for beginners over at TryHackMe. You just need to know where to find it. Okay, so it's a programming language used for managing data held in relational databases. Simply put, SQL allows users to access and manage data contained in relational databases, which are common components in most web applications. The reason why we care about this is because most web applications use SQL, and that means that, well, we could potentially get information from SQL as it relates to those web applications. Why are we learning about it? As far as web app hacking is concerned, insecure implementations of SQL in web apps can lead to a very serious vulnerability called SQL injection. So if people are able to inject SQL statements into your web application because of insecure code, it can lead to a lot of bad stuff. We will learn about SQL injection in a later session, but we should first learn how to use SQL in its intended manner before we learn how to abuse it. We're going to be learning SQL through a little game, and this game is called the SQL Murder Mystery. Let me see if I can grab the link for that right now. Here it is. And I'll share that with the chat. So if you're wondering what links we're going to be using in today's session, all of them are over here. So let's talk a little bit about how SQL databases are structured. So when we talk about SQL, the largest unit in an SQL system is the database. So SQL is used to interact with databases, and the largest unit of data in the SQL system is the database itself. The database contains one or more tables. So this is a diagram of a example database, and inside the database you've got a bunch of tables in the database that hold a bunch of information. So tables themselves can be subdivided into two elements. So this is an example of an SQL table. SQL tables can contain columns whose names identify the data that should be entered into them. So for example, we've got our columns here, our ID column, our name column, our license ID, address number, address street name, SSN. Now you mean an RDBMS, right? So database management system. So the database management system is the software itself, isn't it? SQL is the language in general. So columns whose names identify the data that should be entered into them, and rows which contain the data entries that correspond to the columns that they fall under. So the columns are here, ID, name, license ID, etc., etc., and the rows contain stuff like 1000 for the ID, Christopher Petulli for the name, and you know, these numbers over here for the other columns. So we'll talk a little bit about basic SQL statements now. This statement is used to retrieve all the rows from a specified table, and it uses two SQL keywords, select and from. So we got this statement here, select star from person. It's a system managing it. The MySQL would be the software. The SQL would be the query language used to talk with the DBMS, the database management system. I think so. In the SQL system, the largest object is the database. This is what we're trying to talk about. We're just trying to talk about the parts of the system. So the database is the biggest thing, and then the tables, and in the tables there are columns and rows. So the basic SQL statement here that we're trying to teach is select star from person. So if we go over to the SQL murder mystery, we can actually start running our queries on an actual SQL system. So inside of the SQL murder mystery, if we scroll down, Christian Rink says, no NASA or Facebook hacking? No, not yet. Not yet. Catfile. Catfile says E. Catfile? I'm not too sure what that means. Okay, so if we just scroll on down, we've got a lot of the same information. They talk about entity relationship diagrams, which tells you how the different tables in the database relate to each other. And we're just going to write some very simple statements in the user input boxes over here. So the first one we're going to run is this. Hold on, drag it over here. Select star from person. So we know that in this particular system, in this database, there's a person table. Let me make this a little bit bigger. Okay. So if we do this command, select star from person, this is what we're doing. We're going to tell the database system to get information. So select means get the information. Here we've got star. Star means all of the different columns, and we have to get it from a particular table. From is the keyword that lets the system know that we want it from a particular table. In this case, is the person table. ERDs are a must for RD, relational database management system planning. I mean, I'm not an expert on databases, but I mean I do know a little bit about how to get information from them. So select star from person. If we run this command, it'll get us all of the information from the person table. So select star from person, it gets all the rows, ID, name, license ID, address number, address, street name, and SSN from the person table, and it returns all of the rows. So this is all of the information from this particular table. So that's fine if we want to get all of the information from the table, but sometimes we want to get just certain columns from the table. And in this case, we can select those certain columns. So if we just want the ID and the name from the person table, we would do select ID name from person. And if we were to run that, we just get the ID and the name columns from the table. Okay, so this statement is used to retrieve all the rows, so star, all the rows, all the columns rather, from the specified table. It uses two SQL keywords, select and from. So the select command is the most common SQL command and returns SQL entries depending on which additional parameters are provided. So select means that it's going to get certain entries. So from, this specifies which table to retrieve the data from. So from person, from whatever table name that you want to get it from. So the last important detail about this statement is the wildcard character, which is the star over here. So in SQL, when we indicate star with select, we're indicating all of the columns. So all of the columns, it doesn't really matter how many columns there are, it's just all of the columns. So basic table selection practice, retrieve all of the columns from the interview table. What is the first number in the person ID column? So let's just pretend we want to get everything from the interview table. How would we do this? What would the command look like? And answer this question. What is the first number in the person ID column? So this is going to look very similar to what's on the screen right now. Select star from person. And give it a go. Use any one of these input fields on the SQL Murder Mystery website here. Okay, so let's try this out ourselves. So if we want to get all of the columns from the interview table, we would have to select star from the interview table. So select star from interview. Okay, if we run this command, we see that the first person ID row that's returned is 28508. And what this interview table is, in relation to the murder mystery, is the transcripts from the interviews that are done with various suspects. So in this case, I mean, we don't really care too much about the contents of the interview table, but we do care about figuring out how to get the right information from these things. Okay, so if we wanted to get all of the columns from any one of these tables, so we know that there are these different tables in here. So there's person, there's driver's license, income, solution, crime scene report, etc. Let's suppose we wanted to get everything from the driver's license table. It would be the same thing as our other query here, but we get everything from driver's license. I think that's how you spell it. Okay, and this gets all of the information from the table. We got ID numbers, age, height, eye color, hair color, etc. from the driver's license table. Okay, so the next thing we're going to learn about is, what is the first entry in the car make column? What is the first... okay. So the next thing we're going to do is we're going to retrieve all of the columns from the driver's license table. What is the first entry in the car make column? So give this a try yourself. So go over to the website over here and start putting in your own queries. Retrieve all of the columns from the driver's license table. What is the first entry in the car make column? So we can create this query pretty easily. Can we put the answer in the chat? Yeah, please put the answer in the chat. Christian Rink says, select star from driver's license limit 1. Yeah, that would definitely do it. So we'll talk about the limit keyword a little bit later as well. Okay, so if we go here, so select star from driver's license, and we want to get the first entry from the car make column. So car make equals Acura. So the answer is Acura. If we wanted to just get the car make column itself, we could probably do select car make. Select car underscore make from driver's license and run this. And it just gets the entries for the car make. So Christian Rink also mentioned limit 1. So we can also add these things to our query here. So limit 1 means just get the first entry. If we run that, then only the first entry is returned here. Okay, so our next thing we're going to do is, the answer is Acura. Great, let's move on to more advanced statements. So aside from just this, we can do a bunch of other stuff, like select rows with specific values. Most of the time when we interact with databases, we want specific information, and we can search for that with the where filter and the equals character. So we've got an example over here. So select star, so that's all the columns, from the person table, where the name column equals Courtney Calderwood. Courtney Calderwood. Okay, so we'll give this a try ourselves. So select star from person, where name equals Courtney Calderwood. So here, so we select star from person. Okay, where name equals, and inside a string, whatever name we're going to specify. So it's Courtney Calderwood. Okay, if we run this query, then we get exactly this entry. So exactly this row from the person table. Because in the name column, we've got Courtney Calderwood. So it's just this. So we get all of Courtney Calderwood's information here. Okay, so we're gonna be doing some more specific filtering, and so where is an example of a filter? And filters are what gets you your precise information. So the where filter. The where filter allows very specific information to be returned by a query. So if we wanted to search by name, we would have to know the exact name. And for example here, we can get all the information from the person table where the name, or the contents of the name column rather, are Kinsey Erickson. Kinsey Erickson. So let's go ahead and try this as well. So name is going to be Kinsey Erickson. That's how you spell it, right? Yeah. Okay, run that. And then we get Kinsey Erickson's information. If we didn't know Kinsey Erickson's name, but we did know the ID number, we could search that way as well. So we could do where ID equals some number. So in this case, Kinsey Erickson's ID number is 89906. And if we run this, we get the same result. Or we could, search by license ID number. We could search by SSN number. Anything that's in the table here. Okay, so next thing we're going to look at is the equals operator. So the equals operator in SQL is used with the where filter to return exact matches. If the contents of a row differ by even a single character, the match will not return. So the K in the above example is not capitalized, so a valid match is not found. So if we search lowercase k, Kinsey Erickson, then this doesn't exist because the K has to be capitalized. So like a lot of other stuff in computers, you have to be very precise. otherwise you don't get what you want. So we go here and we search for, if we search by name, and we look for Kinsey Erickson, but with the lowercase e, and we try to retrieve this, it says no data returned, because we have to be precise when we use the equal sign over here. Okay. And we got an ad running on Twitch right now, so we're going to go ahead and take a little break. And while the break is going on, we'll put on the birds. So here's a woodpecker. Here are some woodpeckers. Okay, everybody, we'll be back in about 60 seconds. Enjoy the woodpeckers, and yeah, enjoy the music. So these are kind of noisy little guys. Anyways, we'll put the birds away and get back to the databases. Okay, and Christian Ring says SQL is a great way to teach programming as long as one does not deep dive into joins. I don't do a lot of join stuff when I do SQL. Anyways, let's see what the next thing we need to learn is. Okay, so we're going to do some practice with the where statement. So look into the person table and look for the name Hannah Beverage. So let's practice getting specific rows using these criteria. What street does Hannah live on? So how would you craft this statement using SQL? So we're looking in the person table, and we're looking where the column name equals Hannah Beverage. Definitely dive into joins. Definitely dive into joins. Inner joins, outer joins, left joins, right derms, material views, learn all the things. I mean, I think if we just want to learn about SQL to do some SQL injection, we don't really need to dive super deep into the SQL language. But we do need to do some basic statements. Okay, so everybody, if you know what street Hannah lives on, let us know in the chat. And we're looking for Hannah Beverage. To find things knowing SQL is good, Ailing Circle says Kyron Brook. You are correct. Okay, so let's go ahead and do this ourselves. So we'll go in here and we'll select star from person where name equals Hannah Beverage. Okay, and we'll run that. And they are on Ailing Circle. Ailing Circle, and we've got all of Hannah's information here. Okay, now look at the same person table, but this time search by ID number. So if we know that the ID number is this one over here, so ID equals 10914, what is the name of this person? So this was select star from person where name equals Hannah Beverage. But instead of name, we're looking by ID number. What is the name of this person with this ID number? Okay, let's try this out ourselves. So if we go back to the murder mystery over here, so it's going to be ID. Oh, you know what? This needs to be lowercase ID. So this is one thing you need to keep track of. If they use uppercase or lowercase in the names of the columns, you need to also use uppercase and lowercase there. So in this case, we're looking for an ID number, and the ID number is 10914. Okay, Skyrenbrook says Cinderella Coachman. So we run the query, and we see the name is Cinderella Coachman. All right, great. So I think, do we have one more? Okay, so this time we're going to be searching by the street name. So address street name equals Deer Cliff Circle. What is this person's SSN? So we're going to do another query, but we're going to be searching by address street name. To make it easier, we can do this. SysOS says, after update people, set name equals Stormageddon. I guess, oh, SysOS, yeah, I guess if you want to hack the system, that's how you do it. Okay, I don't think the names on the tables or the columns is case sensitive. Is it not? We should probably do a little experiment afterwards. Okay, so what is the person's SSN? So look at the same person table, but address street name equals Deer Cliff Circle. The person's SSN is something. I thought we were hacksters here. Yeah, we try to be at least. Okay, so let's give this a try. So street name equals Deer Cliff Circle. Okay, and let's just try capitalizing A in address street name. Ah, okay, so address, it doesn't care about capitalization here. So we could make this a capital, we could make this a capital, and it still comes back the same. So it looks like this, well, I mean, this system is case insensitive. So the name of the person is Harley Dearmore, and their SSN is this one over here. Okay? I mean, the name of the tables and the columns doesn't seem to be... Can we do PRO like this? Yeah, it doesn't seem to be case sensitive here. Alright. Okay, let's move on to more advanced SQL statements. So searching for partial matches. So sometimes we don't know the exact name or the exact information, but we want to get something that is kind of close. Sometimes we want to search the database, but we only have vague details, such as part of a name or the last few digits of a number. So this is where we have to use the like keyword. These type of queries require the where filter with the like keyword and the %sign wildcard character. MSEC is raiding with a party of 7. Hello MSEC, nice to see you here. And hello Raiders, my name is The Shy Hat. I do cybersecurity stuff over here on Twitch and on YouTube. And let's give you a special redeem. How about some Hack the Planet? Hack the Planet! Hack the Planet! We're currently doing some study on SQL systems with the murder mystery over here. We're just learning how to use the SQL system in its regular capacity, and we're learning about partial matches. So MSEC, what were you getting up to on your stream? Let me know. And you know what? Let me give you a shout out. Shout out MSEC, there you go. Okay, so these type of queries require the where filter with the like keyword and the % wildcard character. So over here we've got a statement. Oh, you're doing some vibe coding. Were you vibe coding in Python, or JavaScript or something else? Let me know what language you're using. So we select everything, all the columns, from person, where name is like something more something. Something more something. So if we know that the person's name has the word more in it, but we don't know what it is, we could search for partial matches like this. Python on React. Oh, okay, awesome, awesome. Okay, so let's go ahead and try this out. So select from the person table where name is like something something more. So we'll put the wildcard characters over here, and the thing that we're looking for, more in this case, between the wildcard characters. We run the query, and then we get Harley Dearmore, Royce Rushmore, Christopher Moretto, Elroy Galamore, Olivia Morena. So every name that has the word more in it. So we got more. What is today's lesson? Hello world. Hello. Smiling Proud. What's today's lesson? So we're just learning about how to use databases. So it's kind of a crash course on how to use SQL databases with our game, the SQL Murder Mystery. So this is how we do partial matches. So I mean, for example, if you wanted to look for everybody named David, we could do where name like David. So if we do this, then we get everybody with the name David in their name. So Davida, Davidoff, David, Davida, and etc., etc. You made this? No, I did not make the SQL Murder Mystery. I just made the lesson that we're doing, learning about how to use the system. Okay, and we use the like keyword here. So the like keyword is used instead of the equal sign operator when we want to return partial matches as opposed to exact matches. If you don't use like when you do your partial matches, you're not going to get the correct results. So let's demonstrate over here. So if we replace the word like with equals and we run the same query, nothing comes back. So if you want to get partial matches, you can't use the equals operator. You have to use the like keyword instead. Okay, next. So the %sign wildcard character. So the %sign wildcard character is used with the like keyword to return anything on that side of the query term. So if we want something more, then we put the %sign before the more. If we want more and then something, we would put the %sign after the string. Okay, in the above example, the % wildcard characters will match any values to the left or the right of the more string. So we don't care which position it is inside of the string, we just care that the word or the pattern more is in there. Okay, we can also refine our filters as well with the AND clause. The AND clause is used with the where filter to further restrict the results returned, only returning rows that match both parameters on either side of the AND clause. So we've got an example query over here. Select star from person where name equals John Dial and address street name equals Ice House Avenue. We can combine these kind of queries if we wanted to get very specific about the data we want to return. And let's try doing this. So name equals John Dial. Equals John Dial. Actually, let's pretend we know that this person, their name is supposed to be John something. So name like John somewhere, and we're looking for street address, street name. So if we were to run this by itself, we get a bunch of Johns. So John, 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 John. But if we combine this with the AND statement, and address street name equals Icehouse Avenue. Then we only get... Ooh, we gotta spell that thing correctly. Then we only get one entry here. Okay, I like set theory and discrete math. Peaceboy John says, fun fact, my name is John, and you better not be, pardon me? Hey, Peaceboy John, why are you coming in here with such aggressive language? You better not be... Why are you threatening me as the first thing you type in my chat? Don't do that. I'm here teaching people how to use databases, and you come in here and say you better not be a predator? What the hell is wrong with you? I'm serious, what the hell is wrong with you? Anyways, moving on. Yeah. Obviously, I'm doxing real people. This is a game. This is a game called the SQL Murder Mystery. It's got a bunch of people that don't exist. But if you think I'm actually doxing real people, I'm not. If you need some YouTube mods to help you issue some bans, I usually don't get weird people leaving incredibly weird messages. But yeah, anyways. Okay, using the AND clause is very useful when we have a couple of pieces of info to search for, but we don't have exact details. Alright, so what are we doing here? So we're doing another little statement here. Select star from person where address street name is like west something circle. So we don't know, in this case we know that it's west something, so something is denoted by the % circle, and name is like alva something. So in this case we're able to get a match based on this partial information, because we've got a person in the database called Alvaro Kistler who lives on West Peregrine Circle. Okay, I mean, people come into the live stream and they assume that I'm doing something illegal, or I'm trying to, do something unethical. Jeng, hello, nice to see you here. Doing SQLI? We're doing some pre-SQLI. We're just learning how to use SQL. Okay, so these are legitimate functions used for SQL, or they're created specifically for the game. I mean, the game is designed to teach people how to use SQL, so all of the commands that we're learning how to use here, they're real commands. Ira Sakai, hello, nice to see you here. Thank you very much for following on Twitch. Okay, so if we're to look for... What did we look for in here? West something circle. So address street name equals west something circle. So west something circle, and the name is like Alva something. If we give this kind of thing, name like Alva something, and address street name like west something circle, and we get this entry here. Dumping database data, of course. Okay, in the above example, we know that the street name is West Something Circle and the person's name is Alva Something. So we're going to do some advanced search practice. Let's practice our AND and like keyword searches. We know that the name of the person is Jenny something, and they live on Rising something. What is the person's full name? So in this case, we're looking for the address street name. And we're looking for the name. Or I guess you could say I like it. Awesome. Ross AK. Awesome. Okay, so what is the full name of this person? They live on Rising something street. And we know the name of the person is Jenny something. Okay? If you know the full name of the person, let us know in the chat. But otherwise, we can do our query in just a bit. Okay, select something from user where password equals empty string or 1 equals 1. Yeah, SQL injection uses regular SQL statements. It's just that in order to understand how to break a system, it's probably better that you learn how to use the system in its intended way first. A lot of people who do SQL injection, I mean, maybe haven't had a lot of practice using SQL in its intended way. And what is this emote? Oh, okay. We got some great scrolling characters. All right, let's go ahead and try to solve this mystery here. So it's Jenny something, and they live on Rising something. So if we go in here and we look for name like Jenny something, and address street name like Rising something. Okay, so the statement is going to look something like this. Oh, it's delete, is it? Okay, we got the name. The person's name is short Jenny Forbes. For Bess. And this is what the statement looks like over here. Know how to use it before you abuse it. Then you know what you're trying to do. Yeah, this is exactly what we're trying to communicate here. So if you want to learn how to abuse a system, our hack a system, you should know how to use it in its intended way first. Okay, so advanced search practice. Okay. Okay, so we're going to do one more. Next, for the next query, we know that the last name of the person is Living something, and they live on something Boulevard. They live on something Boulevard, and their last name is Living something. What is this person's full name? Okay, so let me type in the information. So it's going to be name is Living something something. And street name, street address name, address street name is going to be something Boulevard, BLVD. So what is this person's full name? Okay, we can go in and we can answer this question. So we go in here, we know that that their last name is Living something. So what we would do is between these wildcard characters, we could put in the word living. And for the address street name, we know that they live on something Boulevard. So it's going to be BLVD over here, with the wildcard character in front of Boulevard. If we run this, we find Hector Livingstone. So Hector Livingstone on E. Eldony Boulevard? Yeah. Okay, so I think the next thing is we're going to do some more... Wait, is this it? Okay, so now that we've learned how to do some basic SQL queries, we're going to do a challenge over at PicoCTF. So PicoCTF is one of our favorite places to learn about cybersecurity and hacking stuff. And the challenge we're going to be doing today is called SQL Direct. So the link is over here. If you've got an account over at PicoCTF, you can access the challenge. So SQL Direct. So here, in the challenge, we're given this description. Connect to this PostgreSQL server and find the flag. Additional details will be available after launching your challenge instance. So we can, so if you're logged in, you can access the challenge, and then you can start up the server where the database is. So click on Launch Instance. And I guess I'm going to have to teach everybody how to log in with their web shell. Okay, so before we do this, let me teach everybody how to open up the web shell. So when you're logged into PicoCTF, you can use a terminal to complete the challenges. After you're logged in, there's a button on the right-hand side of the screen called Web Shell. So go ahead and click on that. And that's going to start up your web shell session. So it's a little terminal that has a Linux machine. And why does it look... It looks a little bit different. Oh, they put it in the full screen by default. Huh. That's new. Hold on. But it doesn't seem to have gone through correctly. I'm just going to close this out. I'm going to click on Web Shell again. That's weird. Okay. So the other thing you can do, can you make a joke? Sure, you can make a joke. So what we're going to do is we're going to open this up in a full terminal on the right-hand side of the screen. So there's a button beside the Help button labeled Pop-Out Web Shell Terminal. You want to click on that. And that's going to start up your web shell in a full screen. Okay, this is a Yo Mama So Big joke. Okay, so Yo Mama So Big, I had to select star from people where size like infinite and with like anything. Name of the challenge. So the name of the challenge we're doing today is SQL Direct. You should be able to find it with this. But yeah, that's an SQL joke for sure. Okay, so after you've opened up the web shell, then you can start, well, I've got so much stuff in here. But anyways, we need to connect to the server, and we'll go directly to the challenge here. And after you launch your challenge instance, they give you a command you can use to connect to the server, to connect to the SQL database. So we can copy this. And I guess everybody can use the same stuff. Okay, the password is Postgres. So once you give this command in the terminal, it'll ask you for a password. And the password is Postgres. So we'll go over to the web shell. We'll paste this in. And then we put in the password for Postgres. It's the same password here. So POSTGRES. When you type in the password, you're not going to see anything appear in the terminal. You're not going to see any feedback. That's normal. So just type in Postgres as the password, hit enter, and then you're logged in. So this is an SQL database that we're logged into. Specifically, this is a Postgres. This is a Postgres system. So it's actually got some different commands than what we would typically look for. So, I mean, if you want to navigate your way around a system that you're not super familiar with, you could look for a cheat sheet. So this is called Postgres cheat sheet, and look that up. So we can, yeah, so we got a Postgres command line cheat sheet over here. I'll give everybody the link if you want to take a look. Jurassic Park? I can do that for you, SysOS.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so the first thing we want to do when we're inside of the database system is we want to figure out what tables exist. So we could search for something like tables. So they say that we're supposed to use \d. Hold on. Postgres get tables. Okay, to list tables in Postgres database, you can use the built-in terminal commands. So we can do \dt. \dt. So let's go back to the web shell. So we're logged in. We'll do \dt to get all the tables. Okay, what's up with the picoctf web shell? What's up with the picoctf web shell? Is there something wrong with the picoctf web shell? The reason why we're using the picoctf web shell is it's that if you don't have a terminal to use, I did ls and nothing, but /dt works. Okay. So the thing about the web shell here is that after we're logged into the Postgres system, we have to use Postgres commands. We can't use regular Linux commands, but \dt will get you your tables. So there's one table here called flags. And so does anybody remember? So if we want to get all the information from a table, what command is it going to be? So it's going to be \question mark helps. Yeah, that's true. On this system, you can do \question mark to get your commands. Describe. So if we want to just get all the information from the flags table here, so it's just like the commands that we used over here. So it's like select star from table name. So if we do select star from whatever table name we want to access, it'll get us all the information from that table name. Yeah, select star from flags also works. So if we go over to the challenge, we do select star from flags. Select star from flags. Most of the time when you give these SQL statements, you need to finish the statement with a semicolon. Otherwise it's let me see if it works without the semicolon. Huh. It doesn't give you anything. Anyways, select star from flags with the semicolon. Syntax error. Let's see. Error at or near select. Line 2, select. Maybe they want it to be uppercase. Ah, right, okay. So this system really cares that you use the correct case, and in this case it has to be uppercase for these commands. So select needs to be uppercase and from needs to be uppercase. Okay, type semicolon now, nothing else. So semicolon does, well, semicolon by itself doesn't give you anything. Sometimes the SQL systems need a semicolon to finish the statements. Sometimes they don't care. So let's try without the semicolon. Without the semicolon, it doesn't give you anything. But if you put the semicolon in, then it gives you something. Why is it still complaining here? Select star from flags, semicolon. Oh, okay. So you can do it over multiple lines. Select star from flags and then semicolon. Ah, okay. So, I mean, this is another little quirk of this system. You can spread out your command over multiple lines, but when you want to execute, you have to put in the semicolon. Okay, so we managed to access the SQL system and get the flag. So we just need to grab the flag, which is right over here, and copy it. Postgres does not execute until the end of the query. Symbol has been found like a semicolon. There are a few. I mean, systems can differ from each other. Some systems insist on like, you know, specific case. Some don't care. Some require a semicolon to finish all of their statements. Some don't, or some it doesn't matter. It really depends on a case-by-case basis. So let's go back to the PicoCTF challenge, and we can submit the flag for SQL Direct. It's a Postgres quirk. Yeah, I mean, there are a bunch of different pieces of software that run SQL commands. So I mean, we can talk about it briefly because we got a bit of time. So we can call these flavors of SQL. So there's a lot of different software that runs SQL. The most common that you'll encounter in the Linux world is probably like MySQL. So there's MySQL, there's MariaDB, which is also connected to MySQL. There's Postgres. There is SQLite. There's a bunch of different flavors of SQL, and the different flavors all have slightly different commands, but overall they all use the same kind of queries like the ones that we were writing over here. So select something from something. SQL via Postgres database versus a SQLite versus a MariaDB, etc., etc. Okay, SysOS says if you like, just remember that SQL is loosely standardized, not strictly. Everyone ignores the standard, basically. Yeah, I mean, this will come up a lot more when we're doing SQL injection, and we'll start doing SQL injection next week on Wednesday. Thank you very much, Wild Wonders, for subscribing on YouTube. Thank you very much. Okay, and why does this person's face appear over here? That's kind of weird. Alright, I think we're pretty much done, so let's go ahead and wrap up today's lesson. So let's review the SQL concepts we learned in this workshop. Structured Query Language, or SQL, is a programming language used for managing data held in relational databases. So, some very basic commands we learned today, stuff like the select command, which is used to return specific info from the database. And we're going to be learning about SQL injection vulnerabilities. Originally, I used the TryHackMe platform to do this. I think I use like a different one now. Let me take a look at my notes. Just a second, everybody. I think we might be using PicoCTF to do this stuff. So the next session is session number 6. Oh, we are using... Okay, so we're using TryHackMe, and we're also doing some OWASP Juice Shop to learn about SQL injection stuff. Okay. So SQL injection basics, part 1, that's going to be the next session on Wednesday. You can use DVWA. Let me just check to see that the DVWA room is still around. Actually, wait. So the TryHackMe DVWA room, we use that, but we also use this room right over here. So it's a special room on SQL injection from... Am I not logged in? Hold on, let me log in. From TryHackMe. Does this room not exist anymore? No, it still exists. Okay. Alright, everybody. Yeah. So that's what we're going to be doing next week. We're going to be learning about SQL injection. SQL alchemy for the win. Yeah. Alright. So let's go ahead and start into our next topic. So for the next topic, we're going to be learning about CSRF, so cross-site request forgery, and this is going to be with PortSwigger. If you want to learn more, the link is over here. So before we start, I'm going to close out some of these tabs I'm not using. Okay. So let's read up on this topic. Usually for these kind of web topics, it's usually something that I've encountered pretty recently that I need to do more education. I need to educate myself more about. So this is less beginner-friendly education topic, and this is more me teaching myself how to do stuff. So what are we talking about today? So we're talking about cross-site request forgery, commonly called CSRF. So in this section, we'll explain what cross-site request forgery is, describe some examples of common CSRF vulnerabilities, and explain how to prevent CSRF attacks. So cross-site request forgery is a web security vulnerability that allows an attacker to induce users to perform actions that they do not intend to perform. Okay, so it allows an attacker to partly circumvent the same origin policy, which is designed to prevent different websites from interfering with each other. Okay, so what do we have in our picture? We got our hacker in his robber outfit, and he's sending change email to pwned@eviluser.net, and they send it over to the victim. When they run this payload over here, it changes their account's email over to the one that's specified in the payload. Or at least that's what I think it's supposed to do. Okay, so let's read about this. So what is the impact of a CSRF attack? In a successful CSRF attack, the attacker causes the victim user to carry out an action unintentionally. For example, this might be to change the email address on their account, to change their password, or to make a funds transfer. Depending on the nature of the action, the attacker might be able to gain full control over the user's account. If the compromised user has a privileged role within the application, then the attacker might be able to take full control of all the application's data and functionality. How does CSRF work? For a CSRF attack to be possible, 3 key conditions must be in place. So there has to be a relevant action. There's an action within the application that the attacker has a reason to induce. This might be a privileged action, such as modifying permissions for other users, or any action on user-specific data, such as changing the user's own password. There has to be a cookie-based session handling in the application. Performing the action involves issuing one or more HTTP requests, and the application relies solely on session cookies to identify the user that has made the request. There is no other mechanism in place for tracking sessions or validating user requests. So it has to be cookie-based session handling only, and there has to be no unpredictable request parameters. The requests that perform the action do not contain any parameters whose values the attacker cannot determine or guess. For example, when causing a user to change their password, the function is not vulnerable if an attacker needs to know the value of the existing password. So this is... If you have a web application that lets you change your password without providing the existing password, that's a bad application. Okay, SysOS says, notes, dbengines.com is a great site to learn all about the different databases that exist and are in use and how popular they are. Thank you very much, SysOS Master. Let me copy that link. I'll take a look at it after the stream is over. Okay, so for example, suppose an application contains a function that lets the user change their email address on their account. When a user performs this action, they make an HTTP request like the following. So what do we have? You need to be able to recover a forgotten password somehow. Oh, forgotten password. Well, I mean, the forgotten password functionality has to be different from changing your password after you're logged in. They're two different functions, of course. So we got a post request to the endpoint /email/change on vulnerablewebsite.com. Okay, and you include a session cookie. and then you include your post data, which is email equals wiener@normaluser.com, of course. So this meets the conditions required for CSRF. The action of changing the email address on the user's account is of interest to an attacker. Following this action, the attacker will typically be able to trigger a password reset and take full control of the user's account. Okay? The application uses a session cookie to identify which user issued the request. There are no other tokens or mechanisms in place to track user sessions, and the attacker can easily determine the values of the request parameters that are needed to perform the action. With these conditions in place, the attacker can construct a web page containing the following HTML. Okay, so it's a web page that has JavaScript. So the JavaScript is going to perform the email change as part of the JavaScript. Sorry, I just lost my place. Okay, so if a victim user visits the attacker's web page, the following will happen. The attacker's page will trigger an HTTP request to the vulnerable website. If the user is logged into the vulnerable website, their browser will automatically include their session cookie in the request, assuming same site cookies are not being used. Christian Rink says if using Flask or Jinja, there is a CSRF token parameter one has to specify inside the form. So Christian Rink, that is one method you could use to prevent the CSRF attack from happening in this case. So this is the second condition here. The application uses a session cookie to identify which user issued the request, but if there's a CSRF token, then this condition becomes false, and you can't do the attack anymore. Music is perfect for this, of course, super dramatic. Okay, the vulnerable website will process the request in a normal way, treating it as if it was made by the victim user and change their email address. Note, although CSRF is normally described in relation to cookie-based session handling, it also arises in other contexts where the application automatically adds some user credentials to requests, such as HTTP basic authentication and certificate-based authentication. How to construct a CSRF attack. Manually creating the HTML needed for a CSRF exploit can be cumbersome, particularly when the desired request contains a large number of parameters or there are other quirks in the request. The easiest way to construct a CSRF exploit is using the CSRF POC generator that is built into Burp Suite Professional. Okay, so select a request anywhere in the Burp Suite Professional that you want to test or exploit. From the right-click context menu, select Engagement Tools / Generate CSRF POC. Burp Suite will generate some HTML that will trigger the selected request minus cookies, which will be automatically added by the victim browser. You can tweak various options in the CSRF POC generator to fine-tune the aspects of the attack. You might need to do this in some unusual situations to quickly deal with quirky features of requests. Copy the generated HTML into a web page, view it in a browser that is logged into the vulnerable website, and test whether the intended request is issued successfully and the desired action occurs. So we've got one lab over here that we can test out, CSRF vulnerability with no defenses. And what we're going to do is we're going to do a little write-up on this, because we want to document all the stuff that we're learning. Let me go ahead and start that up. Professional, Burp Professional. Yep. Okay, so this is PortSwigger, and this is going to be for CSRF. So I'm going to make a directory for this. CSRF, and the name of this lab is what? CSRF vulnerability with no defenses. So if you want to do this one yourself along with us, this is the link over here. So if you're worried about having to pay for anything on PortSwigger, all of the labs over on PortSwigger are completely free, which is one of the reasons why I like to demonstrate using them. So this is CSF vulnerability with no defenses. Okay, so for each one of these walkthroughs, we'll note a few different things. The URL of the challenge, the concept we need to do to understand the challenge, and the method of solving the challenge. Okay, so let me grab the URL. So the concept is perform a CSRF attack. So CSRF, I need to keep track of what these things stand for. Cross-site request forgery. With no defenses in place. Okay, and let's try the lab out. So it says this lab's email function, email change functionality is vulnerable to CSRF. To solve the lab, craft some HTML that uses a CSRF attack to change the viewer's email address and upload it to your exploit server. You can log into your own account using the following credentials: Wiener Peter. Let's take a look at the hint. You cannot register an email address that is already taken by another user. If you change your own email address while testing your exploit, make sure you use a different email address for the final exploit that you deliver to the victim. Okay. Let's access the lab. So the great thing about the PortSwigger Labs is that each time you access the labs, they create a new, what is the word called? It's a new cloud instance that you can use to solve the lab. So what do we have here? So we like the blog, my account. We were given some credentials, right? So you can log into your own account using the following credentials: Wiener Peter. Instance, yeah, a new instance. Cloud instance. So let's log into our account. We go to my account. We put in Wiener Peter. Log in. Okay, your username is Wiener. Your email is wiener@normaluser.net. Okay, and I guess we can get an example of the update for our email. So to do this, we're going to take a look at the request in Burp Suite, which is a pretty common tool for web app security. Specifically, what we're going to do is we're going to take a look at this email change function inside of the Burp Suite browser. The Burp Suite browser it's like a regular web browser, but it's connected to Burp Suite. So proxy open browser, and then we'll grab the address for the lab and put it in our Burp Suite browser. Okay, so username Wiener Peter. Okay, so we're gonna update our email, and we're going to see what it looks like when we update our email. So your email is wiener@normaluser.net. I'm going to change our email to HackerFrogs@HackerFrogs.com. Okay, and then update the email. And then after we do that, it says your email is HackerFrogs@HackerFrogs.com. Okay, awesome. So let's take a look at what happened inside of Burp Suite. If we go over to Burp Suite, then we go over to the proxy HTTP history tab. So proxy and then HTTP history. We can see all of the requests we made through the Burp Suite browser. So all of the GET requests, all of our POST requests, and we're interested in this one over here. So the POST request to my account change email. So we're going to click on that. And we're going to put this in our Burp Suite repeater. So this is the request information here. We can right click on it, and then we can select Send to Repeater. which sends this to the Burp Suite repeater tool. When we click on the tool up here, then we get all the information that we sent to the server. So we send a post request to change email. Let me just grab everything in here, and then I'll show you what it looks like in some bigger font. Okay, you could configure a proxy on Firefox to work with Burp. I'm lazy, I just added the Foxy proxy extension. Oh, no worries, Jang. I mean, I'm lazy, and I use the Burp Suite browser because I don't want to bother setting up the Foxy proxy extension. Okay, so let's just put it over here. So we sent a post request to my account. So this is the endpoint that we're sending it to. My account change email. And we include a session cookie. I mean, we don't need to include the session cookie in our attack. So what we need to do is we need to pay attention to the endpoint that we're sending it to, which is my account change email, and we need to pay attention to the post body data. So the post body data that we send is email equals whatever email that we want to switch it to. So we need to craft a payload on our exploit server to run and to send the link of the exploit server to the victim in this case. So let's go back. So here, we're going to go to our exploit server. Okay, so what's happening here? So this is your server. You can use it to you can use the form below to save an exploit and send it to the victim. Please note that the victim uses Google Chrome. When you test the exploit against yourself, we recommend using Burp's browser or Chrome. Okay, so what this is over here is the URL of our exploit. So after we've finished writing the exploit, we want to send this URL over to the victim. So we got our headers over here. So these are the response headers, and this is the body of the page. So what we want to do is we want to modify the body to include our our CSRF exploit payload. So where do we get that from? We can probably use the same stuff that they were mentioning in the education material. So something like this. So this code here, I'm just going to copy it verbatim, and I'm going to put it in our exploit server. So this stuff from the education portion on PortSwigger, we'll put this as the body of our exploit page. So we need to modify this, of course. This is going to work with the current parameters. So this is a post request that we're making, yeah. And let's see, input type hidden, name email, value equals pwned@eviluser.net. I think we can keep this the same. But what we need to do is we need to change the endpoint here. So HTTPS vulnerable server, we need to switch this up with our web application, which is over here. And so the base address of the lab is over here. I'm just going to grab this, and I'm going to paste it in over here. So delete this, and remember that the endpoint we need to pay attention to is my account change email. So I'm just going to copy this, and I'm going to tack this onto the end of the address over here. Okay, so I think this is all we need to do. So what we're going to do now is we're going to save the exploit. So store. And then we're going to deliver the exploit to the victim. Okay, so deliver exploit to victim. Okay, congratulations, you solved the lab. So we were able to get the CSRF attack to go off successfully. And if we take a look at our access log, we should see a post request to our exploit server. Actually, it wouldn't be a post request to our exploit server, it would be a get request to our exploit server. So where's the last one? So this is the anomalous IP address. So they got, so they accessed our exploit server that we probably sent to them in a link, and that was able to trigger the email change. Okay, so what we're going to do before we finish the lab is we're going to record how we solved it. So method of solve. Let's make this a little bigger. Okay. So first, we want to open the lab app in our Burp Suite browser. Okay. From the browser, log in to our account with our default credentials, with our provided credentials. Provided. So it's Wiener Peter. Okay, and then from the, I think it's the My Account section of the page. Yeah, so My Account, so just click on that and then from the My Account page, enter any email address into, what is the name of the thing? Into the email field, field. Then click Update Email. Okay, and then after you've done that, go to Burp Suite HTTP History tab. So it's the proxy HTTP history. Go to Burp Suite's proxy HTTP history tab. Locate the post request to the My Account change email endpoint. And then click on it. So when you click on this request over here, we just need to, oh, okay, so these are hyphens. Hold on. Need to make sure that these are the same, because people might get confused. So locate that post request and click on it. Note the endpoint is /my account change email. And that the post body contents of the request are email equals something. Okay, so something like this. So we use this information. Thank you very much for following Silva Viperidae. Thank you. We have to use this information when we craft our exploit payload on our server. So click on the, what was it called? Oh, it looks like the server closed. I can't use it anymore. Can I? Hold on. I need to get some more information from this thing. Okay, it's still here, but I don't get access to the exploit server anymore. That's kind of unexpected. Hold on, let me try opening it up again. Congratulations, you solved the lab. Because I solved the lab, I don't get access to the exploit server anymore. That's kind of crummy. Yeah, and I can't go back here either. Or can I? Okay, it lets me. Oh no, I can. Okay, that's great. All right, so go to the exploit server and then put the following payload in the body of the exploit server endpoint. Okay, let me put this in my write-up. Click on the exploit server link, and in the /exploit endpoint body contents, use this code. Okay. So specifically, we need to change the URL in the form action to reflect our lab environment, and make sure to end the URL with the /myaccount /change email endpoint. Okay, so the other thing is the value. So type hidden, name email, value is going to be the name of the input type, needs to be email, and the value needs to be the email we want to change the user's account to. Okay, and from here, click on the send exploit, button, we should solve the lab at this point. Okay, and then just need to check that that's the correct one. So it's deliver exploit to victim. This is the name of the button. Deliver exploit to victim. The log page show anything relevant? The log page shows the GET request from the victim, but that's about it. Okay, so I think this is done. So we're going to move on to the next lab. We might have time to finish this next lab, and then we'll be finished with this section. Okay, so this is done. All right, so how to deliver a CSRF exploit. The delivery mechanisms for cross-site request forgery attacks are essentially the same as for reflected XSS, so cross-site scripting. Typically, the attacker will place the malicious HTML onto a website that they control, and then induce victims to visit the website. This might be done by feeding the user a link to the website by an email or social media message, or if the attack is placed into a popular website, for example in a user comment, they might just wait for users to visit the website. Note that some simple CSRF exploits employ the GET method and can be fully self-contained within the single URL of the vulnerable website. In this situation, the attacker may not need to employ an external site and can directly feed victims a malicious URL on the vulnerable domain. In the preceding example, if the request to change the email address can be performed with the GET method, then a self-contained attack would look like this. So image source is https:/vulnerablepsite.com/email/change, and then the email that you want to change it to is provided as a URL parameter over here. Okay, and then common defense against CSRF. Nowadays, successfully finding and exploiting CSRF vulnerabilities often involve bypassing anti-CSRF measures deployed by the target website, the victim's browser, or both. The most common defenses you'll encounter are as follows. CSRF tokens. So CSRF tokens are very common on web applications these days, and these prevent CSRF attacks from happening. A CSRF token is a unique, secret, and unpredictable value that is generated by the server-side application and shared with the client. When attempting to perform a sensitive action, such as submitting a form, the client must include the correct CSRF token in the request. This makes it very difficult for an attacker to construct a valid request on behalf of the victim. We've got same site cookies. Same site is a browser security mechanism that determines whether a website's cookies are included in requests originating from other websites. As requests to perform sensitive actions typically require an authenticated session cookie, the appropriate same-site restrictions may prevent an attacker from triggering these actions cross-site. Since 2021, Chrome enforces lax same-site restrictions by default. As this is the proposed standard, we expect other major browsers to adopt this behavior in the future. Lax same-site restrictions doesn't seem like it's very secure, but what do I know? Okay, and we've got refer-based validation. Some applications make use of the HTTP refer header to attempt to defend against CSRF attacks, normally by verifying that the request originated from the application's own domain. This is generally less effective than CSRF token validation. So for a more detailed description of each of these defenses, as well as how they can potentially be bypassed, check out the following materials. These include interactive labs that let you practice what you've learned on realistic, deliberately vulnerable targets. So let's see, we've got a lab for bypassing CSRF token validation, one for bypassing same-site cookie restrictions, and one for bypassing referrer-based CSRF defenses. So I think we'll try this lab out next. So bypassing CSRF token validation. Let's take a look at this. Okay, so bypassing CSRF token validation. In this section, we'll explain what CSRF tokens are, how they protect against CSRF attacks, and how you can potentially bypass these defenses. So what is the CSRF token? It's a unique, secret, and unpredictable value that is generated by the server-side application and shared with the client. When issuing a request to perform a sensitive action, such as submitting a form, the client must include the correct CSRF token. Otherwise, the server will refuse to perform the requested action. A common way to share CSRF tokens with the client is to include them as a hidden parameter in an HTML form. For example, oh, interesting. So the CSRF token in this case is this dynamically created when every time somebody loads up a new web page? Because if the CSRF token is the same every time, then it's not really much of a defense at all. Submitting this form results in the following request. So you need to submit your CSRF token and your email to change your email address. Plain text. I mean, well, these labs are designed to be easy, I guess. When implemented correctly, CSRF tokens help protect against CSRF attacks by making it difficult for the attacker to construct a valid request on behalf of the victim. As the attacker has no way of predicting the correct value of the CSRF token, they won't be able to include it in the malicious request. So note, CSRF tokens don't have to be sent as hidden parameters in a post request. Some applications place CSRF tokens in HTTP headers, for example. The way in which tokens are transmitted has a significant impact on the security of the mechanism as a whole. For more information, see how to prevent CSRF vulnerabilities. So what do we got? Common flaws in CSRF token validation. CSRF vulnerabilities typically arise due to the flawed validation of CSRF tokens. In this section, we'll cover some of the most common issues that enable attackers to bypass these defenses. Validation of CSRF tokens depends on request method. Some applications correctly validate the token when the request uses the post method, but skip the validation when the get method is used. Oh, wow, that's really interesting. So if you use the post method to send your email change, they'll check the token. They'll check to see if there's a CSRF token. But if you send a get method, a get request, then they don't care. In this situation, the attacker can switch to a get method to bypass the validation and deliver a CSRF attack. Okay, heard something about iframes being vulnerable to CSRF attacks. Iframes. I mean, I haven't heard very much about that. Okay, so we got CSRF token. CSRF where token validation depends on a request method. Let's go ahead and take a look at this lab. So we got 20 minutes to solve this lab. Hopefully we can do it in that time. So I'm gonna start my write-up. So if you take a look, if you notice, I'm listed as solved all of these labs. I haven't solved all of these labs in years, but I'm still using the same account, so that's why it lists me as having solved a lab before. You can do it. We'll see. So I did do a lot of PortSwigger Labs maybe like 4 years ago. when I was working in my web app security job, but it's been a really long time since I've done those, since I've done these labs and worked that job. Okay, so the URL of the challenge, the concept we need to understand to solve the challenge, and the method of solving the challenge. So this is the lab here. I mean, the good thing about these labs is that they basically tell you how to solve the lab. They say that the token validation depends on the request method. The concept is bypassing CSRF, where the method of the request determines if the CSRF token is used. Okay, it's a pity that the subtitles don't work and I can't understand what you're saying due to my poor knowledge of English. Tribune, hello, nice to see you here. And yeah, I'm sad to hear that. If you ever watch the videos have accurate translation, but the live streams do not, because we're not because we're doing this in real time. Okay, so let's go ahead and start the lab. So we got our environment over here. We're gonna put it in the Burp Suite browser so that we can observe what's going on. Okay, so I'm just going to copy this. Actually, let's access this lab first. Maybe try the VODs or vids where the subtitles should work as expected. They definitely work for normal videos, but the VODs might not. They might not work for VODs. I'm not really sure about that. Can't you add subtitles on Twitch too? I'm not too sure about subtitles in Twitch. Somebody let me know if there is the option for subtitles on Twitch, because I really haven't taken a look at that before. Okay, here's the lab here. So CSRF, where token validation depends on request method, we can click on my account and then log in with our provided credentials, Wiener Peter. There is, okay, that's good to know. You might want to try watching the stream on Twitch, Tribune, and then maybe you can see the subtitles there. Okay, so the email we're gonna check it. We're gonna change it to is HackerFrogs at likeandsubscribe.com. HackerFrogs at likeandsubscribe.com. Okay, we'll update the email. Oh, okay. So our domains can't have the underscores. Okay, so likeandsubscribe.com. There you go. Have a SysOS master as backup. Yeah, that's I don't know if everybody can do that though. Live subtitles is always a little bit janky. Yeah. Okay, so here we've updated our email, and what we need to do is we need to take a look at what happened. So we're gonna go over to Burp Suite proxy, HTTP history, and then go down to the post request. Okay, down here. So post request to my account change email. So this is pretty similar to the last one. We'll put this in the repeater so we can take a better look. So like everything, like the previous lab, we're sending our request to my account change email, this endpoint. And we see here that we include an email and a CSRF token. So because we know how the application works, because we got it from the name of the lab, we could change this post request to a GET request. And in this request, we're going to omit the CSRF token. And we're going to include the email as a URL parameter. So to include this as a URL parameter, we send the URL parameter and we attach it to the end of my account change email, like this. And we're going to change this from a post request to a get request. Actually, I'll do it like this. So right click and then change request method. That'll change it over to get. And because it's a get request, there's no body. So the body's usually included at the very end over here. You might need to add this to your OBS try for Twitch closed captions. Oh, yeah. Let me take a look. Twitch closed captions. I mean, the thing is I'm not using regular OBS. I'm using Streamlabs OBS, so it might be a different plugin. Oh, why is it included twice? That's weird. Okay, so we'll change the email to modified. And then we'll send this off. So click on send. Okay, so this comes back as found, and then we'll check our application. So that did go through. So our email was modified. So the email is now modified. We were able to send the GET request successfully, and we bypass the CSRF token. So all we need to do is we need to craft the exploit, and then send it to the victim, and we should be finished. So go over to the exploit server. Okay, and so the only thing we need to do is we need to paste in our body. So the body portion of the web page should be the same, essentially the same as the previous lab. So let's go ahead and get the payload from the previous lab. Previous lab is here. Oh, I forgot to put a number on this one. Okay, so we got our code. Let's copy that. And then we'll go back to the application. So this is the exploit server. Paste in our form data here, and we change the method. So the method is not going to be the post method because the post method uses CSRF tokens. So we change this to the get method. And in this case, we're not doing... I think we don't need to... Yeah, we don't need the input type necessarily. Hold on. Let's go back to the description of the lab. So the learning material was over here. I think it was this. Self-contained attack would look like this. So image source. So we can just put this image source information as our payload. So I guess we didn't need to use the same payload as the last one. Okay, so back here, we're just gonna replace the entire contents. And the email, well, I mean, we can keep this email, this is fine. And we just need to get our lab URL. So the lab URL is over here. And we'll just paste it in here. We have to remember that the endpoint is different. So the endpoint that we want to use is, I think it was like my account email change. So my account /email change. let me just double check that. My account, change email. Okay, so it's got to be the same thing. And I think this should be it. This should be all we need to do. Okay, we've got an ad running on Twitch right now, so we're just gonna take a little break and put on the birds. How about these birds? Okay, we'll be back in about 60 seconds, but enjoy the music and enjoy the birds. I love these guys. They're so goofy. Okay, and let's put the birds away. Get back to the hacking. So this should be the correct payload over here. So we're just gonna deliver the exploit to the victim. This should finish the lab, but yeah, because this is a GET request that we're sending, this should be fine. So deliver exploit to victim, and congratulations to solve the lab. Okay, great. So that worked. We just needed to send them a link to our exploit server, and in the exploit server, it tries to load up an image from the vulnerable website that includes the email that we want to change the victim's account to, included as a URL parameter. So it's done. Okay, so let's do our write-up. Hey, thanks guys. If you're on Twitch, you can use this emote over here. The Shy 31 was it? Let's see. Flag, like this. Yeah, this one. Okay, so let's do our write-up. So this should be lab number 2. Let me go ahead and rename this thing. Okay. So the let's see. What other emotes do we have? We've got like a typo emote, and we've got a the Shy 31, the Ha emote, which is pretty funny. There we go. They like this one. Okay, so the method to solve for this one is open up the lab in the Burp Suite browser, and then log into the app with our provided credentials. Wiener Peter. Oh, that's not how you spell wiener. And then what we do after that is go to the My Account page and enter any email you like into the email field. Then click on Update Email. Okay, and then after that, go to Burp Suite and click on the proxy HTTP history tab. Okay, locate the post request made to the /my_account/ change email endpoint. So a lot of this is the same as the previous lab, but the payload is different. Okay, so we locate that, and we need to put this in the repeater to do our test. So right-click on the request window and select Send to Repeater. So this is what it looks like in Burp Suite. You'd go over to the proxy HTTPS tree, and then for My Account Change Email, right-click on it and then select Send to Repeater, like this. So this is going to send this particular request to the repeater, and what we need to do is we need to make a number of observations. So we are told that this application will ignore the CSRF token if the request is made with another HTTP method. So we can change the request method from post to get, and then include the email parameter as an URL parameter. So the URL parameter is going to be !email equals email here. Okay, so after we do that, after the request has been modified, send the request, and we should see that our email address for our user has been modified. Bypassed the Twitch emote. Yeah, we get a combination. Which flag is that? Which flag? So it's a checkered flag? Oh, it's a regular emote. Oh, awesome, awesome. Thanks for letting us know, Jeng. Yeah. Okay, so send the request, and we should see that our email for our user is modified. So this confirms that the app uses, well, the app fails to use the CSRF token if the request method is not post. So we can use the following payload for our exploit server. Our exploit server body section. Okay, so the payload is this one over here. Okay, so note that we need to change the URL to reflect our lab environment. Change the URL to reflect our lab environment and make sure the endpoint is /myaccount /change email. And lastly, that we include a URL parameter. It's going to be email equals pwned@eviluser.net. I mean, does it matter? I wonder if it really matters which email that we change the user's account to. Hold on. To solve the lab, use the exploit server to host an HTML page that uses a CSRF attack to change the viewer's email address. So the actual email address really doesn't matter in this case. Burp Suite versus OWASP. Burp Suite versus OWASP? Are you talking about Burp Suite versus OWASP Zap, the Z proxy or whatever? What is that thing called? Zap proxy. This thing. I used to be kind of enthusiastic about teaching people how to use the Zap proxy or the Z-attack proxy, but it's really not the tool that people use in a professional setting. Anybody who does a job doing web app security testing is going to be using Burp Suite, which is the tool that is endorsed by PortSwigger.net, which is a really popular platform for learning about web app security settings, web app security stuff in general. Anyways, let me finish up my write-up and then we can move on to the last thing today. Okay, so we include a URL parameter and click on send exploit to victim, and we should be done. Okay. Or Kaido as a trailing second option, then man in the middle proxy as a third, then Zap, then Zap. Okay, so everybody, we're going to be moving on to the last topic today. So the last topic today is going to be, we're going to be taking a look at a very popular web application and treating it like we're doing a security assessment. So we'll do this for about 2 hours or so, and we're going to be taking a bunch of notes while we do this. This is going to be the last topic of the day, so this is topic number 5. And we're going to be doing this over at HackSmarter. So HackSmarter is another web app security education platform. Well, it's not a web app security education platform, it's a cybersecurity education platform. Let me pull it up. First of all, I probably want to use Burp Suite in this case. This is the link for the course. Let me know if this link works for everybody. You need to be logged into the HackSmarter platform. So what this is it's a hosted version of the OWASP Juice Shop online store. So OWASP Juice Shop is a very well-known application for doing web application security testing, and there are a lot of vulnerabilities that you can test out on this application. Jang says, Zap, it's just Nikto with a GUI, change my mind. I don't know if I'm going to be able to change your mind on that. I don't know too much about Zap anymore. So what are we doing in this particular lab? In this lab, this is the objective in the scope. So Juice Shop has engaged the HackSmarter Red Team to conduct a comprehensive black box penetration test on their global e-commerce platform. Your objective is to identify and exploit critical security flaws, specifically focusing on the OWASP top 10 to demonstrate the potential for data exfiltration and service disruption. You should document the vulnerabilities in a professional penetration test and submit it to our team for review. I mean, we're not going to be submitting a penetration test report, but we are going to be taking a look at the application. So let's go ahead and get started. So they want us to launch the application over here. So click on launch, and that's going to start up the cloud instance. So from here we need to connect. So we're just going to click on systems over here, and we're going to download our VPN configuration. So the machine with the HackSmarter Juice Shop application is at this IP address on the HackSmarter network. We don't have access to the network right now, but we can get access once we download our VPN key. So we're just going to click on download VPN configuration, and that's going to download the key. So the next thing we need to do is we need to access the network by using the VPN key. So let's go ahead and do that. So this is going to be our platform access tab. Platform access. I think if you don't have access to the HackSmarter platform, you could probably find like a free version of the HackSmarter Juice Shop over here. So juiceshop.herokuapp.com. So if you want to access this without having to log into HackSmarter or have an account there, you can use this link as well. The problem is that it's not always online. Sometimes it gets taken offline by people doing testing against this thing. Application error. An error occurred in the application. The page could not be served. Interesting. Let me try reloading the page. So could somebody tell me whether or not this is up for them? This frog is insane. Let me know. Let me know if this link works for you, or if you get the same error message that looks like this. See, the other thing you could do is you could go to Try Hack Me. I'm pretty sure Try Hack Me is a version of the Juice Shop as well. Let me see if I can get everybody a link for that. Yeah, the HackSmarter Juice Shop. Okay, so if you want to access the Juice Shop and you don't have an account over at HackSmarter, and you do have an account over at Try Hack Me, you could try accessing the Juice Shop over here. But we're going to be using the Try Hack Me access. Okay, so platform access. This is going to be in our downloads directory. And where is it? This one. So I'm just going to copy this over to my VPN keys directory. Same error on Chrome. Okay. Okay, I've got all my VPN keys here. Let's go ahead and access the lab. So the other thing I'm not completely sure about is whether or not they've made any modifications to the HackSmarter Juice Shop from its regular incarnation. Here we go. Okay, so let's VPN in. Now the site is accessible. Are you talking about the Heroku one? Or are you talking about the Try Hack Me one? Okay, so we should have access to the HackSmarter VPN private network now. Let's give it a try. So this IP address right here, we'll try pinging the thing. Okay, we've got access. Okay, so we've got access to the Juice Shop now. We just need to... I guess what we could do now is we could do an Nmap scan. So the Juice Shop is a web application, but there might be other ports open on the web server. So what we can do is we can just run an nmap scan here. Kind of like this. Okay. So we've got port 22 and port 80 open. I think there was a couple of like non-standard ports open on the Juice Shop as well. But what we can do is we can start doing a little write-up over here as well. Okay, so the Juice Shop, we're gonna treat this like it's a regular box. So the first thing we're gonna do is we're going to separate this into sections. The first section is going to be initial scans, and we'll report what ports we found open. So it looks like there's only 2 ports open, port 22 and port 80. Comrade Soul, hello, nice to see you here. So port 22 and port 80. So initial scans, nmap reports, ports 22 and 80 are open. Okay, and then we can take a look at the application itself. So we go over to HTTP, this thing, and this is the OWASP Juice Shop over here. So being a web application with a vast number of intended security vulnerabilities, the OWASP Juice Shop is supposed to be the opposite of a best practice or template application for web developers. It is an awareness, training, demonstration, and exercise tool for security risks in modern web applications. The OWASP Juice Shop is an open source project hosted by the nonprofit Open Worldwide Application Security Project, OWASP, and is maintained and is developed and maintained by volunteers. So, OWASPJuiceShop.com. Huh, I didn't know. Let me take a look. New speaking, port 22, no SSH, and port 80, so HTTP stuff. Yeah, that's exactly what's going on. So we can do remote login if we had a username and password. But if anybody wants to take a look at the details for this particular application, it's over here. This isn't the application itself, but it's a lot of information about the application and all the different vulnerabilities you can test out using this thing. Okay, so let's dismiss. So this website uses fruit cookies to ensure you get the juiciest tracking experience. Let's see, me want it. Okay, sure. If you're over 1, there's gin and juice shop. Oh, okay. Actually, I have heard of this one. I haven't seen it out in the wild, though. Hold on. So Gin and Juice Shop is a deliberately vulnerable web application designed for testing web vulnerability scanners. Put your scanner to the test. Okay. So, oh, this is PortSwigger. So this is an OWASP. This is created by PortSwigger. So the people that make Burp Suite. You know what? I think I might want to take a look at this in further detail later. But yeah, thank you very much for reminding me of this, MSEC. But I'll put this in my browser to look at later. Okay, so what we're looking at is the Juice Shop here. And what we want to do is the first thing we want to do in any web application security tests is we want to walk the application. We want to determine what all the endpoints are. So we can, let's see, we can click on account, and then we can click on login. And let's see if we can register. So not yet a customer. So we can register an account. So we can put in any email we want, I guess. So we can do... let's record all the endpoints that we find. So nmap reports port 22 in open or open. So port 22 will just, this is SSH, and port 80 HTTP. Okay, and endpoints found. I guess what we could, I'm not too sure if we're going to be able to fuzz this application in the traditional way, but I mean we can give it a try. So what we're going to do is we're going to go over to our fuzzing tab, and we're going to do something like GoBuster. Let me try GoBustering this. GoBuster this URL right here, and we've got all of our typical directory list names over here as well. Thank you very much for gifting a membership. Christian Rink, wow, that's very generous. Thank you for gifting to HackMe132. Thank you very much. Much appreciated. QVQ, hello, nice to see you here, and I'm doing okay. Let's do all the things to celebrate the gifted membership. Okay, all the things.
This one's dedicated to all the hackers.
Okay, so we run our GoBuster scan. So the server returns a status code that matches the provided options for non-existent URLs. So length 75055, please exclude the response length or the status code or set the wildcard option. To continue, please exclude the status code or the length. So the status code is 200. I mean, we can't exclude 200s, but we can exclude the length, which is 75055. 75055. Let me figure out how to exclude the length with GoBuster. Just a second. GoBuster exclude length. Okay, so exclude length. Oh, is it just exclude length? Dash exclude length. Okay, let's give this a try. So it's the same thing. Exclude length 75055. Okay, so we'll just leave this running in the background. So what we're doing is we're fuzzing the application. So at the same time we're fuzzing the application, we can keep track of the endpoints that we find. So for example, there's what? What? Okay, we're getting flags for stuff that we didn't do. I guess what we did was we fuzzed the application, and it might have triggered some flags in the application. Okay, so endpoints found. So endpoints found via regular browsing. So we found the /register endpoint over here. And this is for user registration. Okay, so I'm currently running and testing live captions. For live captions, this works pretty decently. Maybe this is an option to go with. Okay, let me take a look at. Well, let me copy the URL. Thank you, SysOS Master, because I certainly do want more people to be able to understand what's going on in the live stream, even if they don't speak English. But that's closed captions, not necessarily like translation or subtitles. But thank you nonetheless. Okay, so /register for user registration. Did we find anything yet? Oh, we found some stuff. So there's security.txt, there's profile, there's assets, there's redirect, FTP, security.txt. So we found some stuff by what is it called? Fuzzing. Look after stream? Yeah, I'll look after stream, thank you. Okay, so we'll take a look at this stuff a little bit later. But first, we're going to do some regular application walking. So application walking is trying to figure out what all of the regular web pages are. And but first of all, let's register our user. So our user registration, email, HackerFrogs at likeandsubscribe.com. Okay, and our password is going to be something. Password must be between 5 and 40 characters long. Okay. And we've got a security question. So one thing we need to understand is that security questions are not supposed to... Modern applications should not be using security questions because security questions can be determined by people who are not the actual user. So, what's your favorite movie? My favorite movie is Hackers. Okay, and we'll register our account. Did that work? You successfully solved the challenge repetitive registration. Follow the dry principle when registering a user. Repetitive registration, does that mean that we are able to register the same account over and over again? Can we overwrite accounts by registering? I mean, that might be it. Anyways, we'll try logging in first. So account, login. So security question should be for contract-based uses, where the contract dictates a safe word and the question is like, what is the security answer or something? I mean, the way the security questions are set up can also make it more or less safe. So login is HackerFrogs at likeandsubscribe.com. Okay, and the password is the password we set. Log in. And we should be logged in. Okay, we're logged in now. Alright, and it looks like there's a search endpoint as well, as we see up here. I'm guessing this is for product search. We found some more. Status 500. Huh. Okay. I get a feeling we're going to find a lot of stuff from our fuzzing here. Including a robots.txt, of course. Alright. So we found a register endpoint. We found a search endpoint. And I'm guessing this is for product search. Now that you can create an account with a password length different from each other, did we? I'm pretty sure I updated them. Hold on. I think I'll try registering an account again and see if I can overwrite my account. So we can first I'll log out. Kinslayer has rated the channel with 2 viewers. Thank you very much, Kinslayer. And how was your stream? Let's give Kinslayer a shout out. Shout out. Kinslayer. Here you go. Kinslayer, what were you doing on your stream? Are you an InfoSec streamer? Are you on infosecstreams.com? If you're not, you should register there. Kinslayer, yeah, you're on there. Awesome, awesome. So this is a website that has a lot of streamers who stream InfoSec content for YouTube and for Twitch. Okay, so let's take a look. So /search for product search. I guess we can talk about some observations. Observations. Okay, was doing over the wire. Awesome, Kinslayer. Over the wire, yeah, there's a lot of good stuff over there. Were you doing Natus, or were you doing Bandit, or are you playing another game? Let me know which one you're doing. So overthewire.org. This has a lot of different CTF war games. Good stuff for learning security. And thank you very much for following Wolf2201. Thank you. And thank you very much for the subscription. Much appreciated, Wolf201. You just subscribed for 3 months. Resubscribed for 3 months. Thank you very much. let's give you a fun video routine. How about some, oh, Prison Break, The Devil's Bedroom. There you go.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom.
Sometimes the firewalls have more servers than the Devil's Bedroom. What? Anyways, thank you very much for the subscription on Twitch, Wolf201. Thank you. And thank you very much for the follows, Kinslayer and Fritz. Thank you very much. Okay, so, yeah, so if you're interested in more war games, Over the Wire is a pretty good choice. And we're just going over all the security flaws on the HackSmarter Juice Shop. There sure are a lot of them. Okay, so observations. The application uses security questions. Most likely for password reset. And security questions are no longer recommended as a valid factor in password reset functions. There you go. You had a password, you had a 5 password length on the first input, and on the second, for confirm password, you only had 4 characters, and the account was created either way. Huh, that's really funny. Let me confirm that. Let me confirm that, because that is a vulnerability. Well, that is a flaw, rather. Okay, so we'll go over to our account, we'll click on login, and then we'll try to re-register ourselves, just like what it says over here. Repetitive registration, so we'll click on not yet a customer. So we'll try to clobber ourselves. HackerFrogs at likeandsubscribe.com, and the password we're gonna do, okay, and for the repeat password we just do 3 characters. And here it's still okay. Oh, passwords do not match. So I guess the passwords do need to match when we do this. I mean, the other thing we could check is whether or not we can manipulate this when we're sending it through Burp Suite. And you know what? I think I'll start putting all of our requests in Burp Suite now. So over in the Burp Suite browser, we'll put it over here. We'll try registering here instead. Okay, so account, login, click on not yet a customer. So we'll do email, HackerFrogs at likeandsubscribe.com, password, okay, passwords do not match. So, I mean, it says passwords do not match here, so that's good. So I'll create this with a different password than the password we created for the other user. Okay, the security question will do a different one. Oh. Why can't I choose a security question? Hackers is my favorite movie, but they don't let me... It might be something wrong with the browser here, though. Because they don't let me open this up. What's wrong with my Burp Suite browser? Oh, no, now it lets me open it up. Why didn't it let me open it before? This cannot be changed later. Okay, so click on register. And if it actually lets me register, even though this user exists, that means you can clobber the user registration. It was loading? Yeah, maybe it was loading for a long time. Okay, so did this come back? Yeah, the server might be really slow for some reason. I mean, we are clobbering it. Well, we are like, sending a lot of requests. So that might be why the application's not responding very quickly. Uh-oh. This looks like... This looks like the server might have gone down. Okay, let's try reloading the page. Okay, it says it's still running. Server ban or down? I mean, maybe. It says it's still running though. This didn't come back. Let's see if we recorded anything in our HTTP history. Okay. So this is a bunch of... Okay, so it looks like we're actually sending like an API request. So we send an API request to users over here to register our user. So let's see if we can repeat the request. How does one get into this field? GoBuster doing DOS for the lulz? Yeah, maybe. But Ryan Pereira, hello, nice to see you here. How does one get into the field? Well, we've got a little guide over at this link. Okay, let's do some new music. How about some of... Oh, Void Stranger. I really like this game. I don't know if I'm going to be playing a lot more of this on stream, but it's got a really good soundtrack. Mythical refresh pull? I don't know. Okay, through pain and suffering. Yeah, kind of. All right, so we've got our API call that registers the user, and we can... Well, let's try sending it. Send. Does it go through, or is the server down? You know what? Let me... Connection refused. Huh. Did I just get... Did my IP address just get, like, banned? Connection refused. Let's see if I can just, like, pull up the Juice Shop normally. So let's just go back to the landing page. No, I can use the application. VPN down? I mean, let's try to log in. Invalid email or password. Invalid email or password. Oh, we were able to clobber. Yeah. Can't even skill issue, can't even pentest a website. Yeah, no, we're pentesting it now. It turns out that we didn't get banned, but for some reason the GoBuster isn't working. Hack the planet. Thank you very much. Okay, so if you're wondering what we're looking at today, we're looking at the OWASP Juice Shop. We're looking at the version of the Juice Shop that's hosted on HackSmarter, but actually this is probably the better version. This is probably the better version that you can use. They also have a version over at Try Hack Me if you don't want to use HackSmarter for some reason. Okay, so we'll try this again. We'll try the fuzzing one more time, and we're record all of this in GoBuster. .txt, or GoBuster1.txt. So just run this in the background. In the news, they have an AI that's so powerful they're not releasing. The AI can hack computers. Victor86, yeah, are you talking about the, what was it? Opus Mythos? No. It's Claude Mythos. Claude Mythos, right? I've heard a lot about that stuff, and it's kind of scary. It sounds pretty scary. Mistral? I don't know about Mistral. Is that a new thing? Or Mythos? Claude Mythos. Mythos? Is that what it's called? Wait, what did I say? I wanted to say Mythos. Okay. So the application uses security questions, most likely for password reset, and security questions are no longer recommended as a valid factor in password reset functions. So we're just going to make more observations over here as we go along. The application allows username re-registration. Which means you can register the same user with a different password. You know, if if it allows you to register the same user with a different password, then we could potentially register like the admin user again. That'd be really bad. Claude Mythos is too dangerous to release given its exceptional cyber hacking capabilities. I did hear that, yeah. Okay, based on the amount of security patches from the latest Windows update, it makes me think it's real. Pretty scary, yeah. We've seen how quickly AIs can just use Reddit to answer things even when prompted and not prompted as well. I mean, you could probably do that with the Juice Shop. Remember trying Juice Shop? I always made it crash. MC25, hello, nice to see you here. And Huntingbird, hello, what is up? We're pen testing Juice Shop today. You can get your own version of Juice Shop over here. We're using the one from HackSmarter. Okay, so re-registration is a real thing, and we were just able to do that. You can register the same user with a different password. So the other thing we need to do, if we actually want to take advantage of this, we have to find the email addresses of valid users. Okay, just get my CRTA in my third certification. It's my third certification. CRTA, is that like a Hack the Box certification? Which company is that from, the CRTA, Huntingbird? Let me know. But Juice Shop. Juice Shop's is definitely a classic. Okay, where's our Juice Shop? Here it is. So security policy... Delete cookie to clear hacking progress. Don't think I'll do that. So we did success. Success, role customer, deluxe token, last login IP. So I mean this over shares. Is active equals true, ID equals this, email. Security answer equals hackers. Okay, so what else can we do from here? We've proven that we could that we can clobber users and we can re-register them. Certified Red Team Analyst. Oh, Cyber Warfare Labs. I don't know that that platform. Can you give me a link? But yeah, let's continue walking the application. So we're logged in now. And we can go over to Account, Orders and Payment, Privacy and Security, Logout. So we can go over to the Privacy Policy. So this is the Privacy Policy endpoint. So let's try to keep track of all of these endpoints we find. Privacy Security. You solved the challenge. Read our privacy policy. That's good. Cyberwarfare.live product, Red Team Analyst CRTA. Oh, awesome, awesome. MND, are you also a user of that platform? Okay, so this next one is privacy policy. Read the privacy policy. I'm not just looked up the site. Oh, okay, okay. Diva says, got CRTS V2 from Cyberwarfare Labs 2 days ago, but it's kind of meh experience overall, to be honest. What can you tell us about the experience, Divas? Let us know. Thanks. Okay, let me take a look at this really quick. Okay, certified red team analyst, fully hands-on, what was it? Dang it. Fully hands-on course for beginners, get study materials including practice lab, video, and manuals. Understand the mindset and TTPs of adversaries. Course will definitely help in journey to become a red team something. Courses for anyone interested in red teaming offensive information security. Okay, Hummingbird says it's not an advanced cert, it's still better in practice than EJPT version 2. I mean, EJPT version 2 is not very advanced at all. I know because I took it and I got it. I mean, it might be a good introductory certification. Okay, Tifa says, I don't know how much I can say, but they hard-coded web vulnerabilities into a site, so you had to use the exact payload to trigger the malicious behavior. Really not that great. Hard-coded web vulnerabilities into a site. Wait, did they use like a standard site for testing? But anyways, okay. So let's continue on with our with our testing. So OS Juice Shop. So we read the privacy policy, and next, let's take a look at the other parts of the website. So my account, order history, recycle, my saved address, my payment options, digital wallet. Okay, so there's order history. So I'm guessing that this is going to have your order history. Otherwise it doesn't make sense. Okay, vulns are always coded in a website. I mean, can you explain a little bit more about these hard-coded web vulnerabilities and how they'd be different from vulnerabilities that you would find on a standard site, Deepus? I don't quite understand either. Okay, let's take a look at some other parts. Oh no, we're not logged in here. So your basket, I'm guessing that your basket has your basket. Basket. Users shopping basket. Okay, so your basket, total price. So this is where you would check out. Order history, recycle. What is this recycle part? Request recycling box. Oh, interesting. So you can order a recycling box. Quantity in liters. So order a recycling box from this endpoint over here. Sure. Okay. So let's see. Diva says, no, it's basically like, let's say you have to do an XSS. You have to use the exact XSS payload they wanted you to use, because what they basically did was when you enter this exact string, it will trigger the behavior a real access is supposed to trigger. So they basically just said in the code, if the user sends the string XYZ, then send a request to the user. So they didn't actually model an XSS vulnerability. They modeled how the server should respond to like a specific post request or like a specific get request or something like that, right? I think I understand what you're trying to say. Okay, so the next one is recycle. So this is to order a recycling container. ID was just coded into the app. The vulnerability wasn't really existent. Oh, okay. That sounds pretty... That doesn't sound very professional, yeah. So LFI to etc password, you get you a rigged etc password. Okay. Many types and kinds of vulnerability from outdated to day 0. Okay, so we're just walking the application, trying to figure out all the regular endpoints, not the ones that you would get from fuzzing the application. Okay, so where are we? Account, ordered. So order history, recycle, my saved addresses. So we've got, this is an endpoint that gives you your address. Add new address. Okay, so add an address from this endpoint. View / input addresses. Okay, its main IP links to Ascension Island, which is a place where the Pirate Bay lived. The main IP links to Ascension Island? Are you talking about the... what is the name of the platform? The platform we were just talking about. Cyberwarfare.live. Okay, Huntingbird says, I basically had to go through an LFI read content to get a password SSH and pivot through the network? Maybe I should check out this this platform later. Do they have anything that's not paid? Or is everything paid on this platform? Okay, so all these different endpoints. Next one is going to be my payment options. So my payment options, I can only assume. The server has been restarted. Your previous hacking progress has been restored automatically. So my payment options, this is where we put in credit cards. Okay, so this is where we keep track of our credit card information. Saved payment methods. So let's record this. Okay, so this is view / input new credit card information. Okay, and next. So we can put in our credit card information here. Digital wallet. So I think this is an option where you can connect like cryptocurrency wallets. Digital wallet, add money. Try our new crypto wallet. Our new crypto wallet. So there's wallet web 3, okay, and this endpoint is called wallet. So let's record these. So we can just put in a number and deposit it? That's kind of funny. So we can view slash update digital wallet info. Scammers, I mean crypto bros. Yeah, of course. Okay, so they've got another endpoint called like crypto wallet or something there, right? Wallet Web 3. Connect your MetaMask wallet balance 0 ETH. So they're taking in Ethereum. Wallet Web 3. Let's record this endpoint. So why are we doing this? The reason why we're recording all of the endpoints here is that we can investigate each one of these endpoints systematically if we were doing a security test. So we would check the register endpoint for security vulnerabilities, then the search, and then just make our way down and check each one of these endpoints to see if there's anything that we can abuse. So, I mean, you should try to be as organized as you can when you're doing stuff like this. View update crypto wallet info, sure. Okay, so the next thing is going to be digital wallet. So we've explored all of these different endpoints. So there's policy, privacy policy, request data export, request data erasure, change password, 2FA, last login IP. Okay, Grisson Ring says the cat and mouse game between hackers and security experts is so funny. The funniest thing about it is they need each other in order to improve. I mean, it used to be very, very hush-hush. It used to be that hackers would never share any of their techniques or any of their secrets with anybody, and I think it was a much weirder world back then. So privacy policy, the next one is data export. So security policy, data export. What do we do here? So we can export our data in either JSON format, PDF, or Excel. Data export will open in a new browser window. Okay. So this is data export. Export user data in various formats. Oh, we get all these connection refused after a while, huh? There's a time you could get arrested just for doing a pen tester. I mean, you mean by doing like digital pen tests, like, you know, like web stuff? I know there's one really famous instance of physical pen testers getting arrested, and I think it was pretty well documented on Darknet Diaries. Darknet Diaries, and I think the name of the pen testing firm was called Coalfire. The Courthouse, this one right over here. If you're interested in learning about how real-life pen testers got arrested, you can check out this episode here. It was a big, well, you know what? I should give this episode a re-listen again. It's a good episode. There's a recent update to that story. Was there? M&D, let me know what the update was. Okay, so that's, request data export and also request data erasure. So I mean, these really get me thinking that this must be like a European application, because like GDPR makes it mandatory that you can do like data export and data erasure. Pentester got arrested? Yeah, the pentester got arrested. Check out the link. So data record. This was export. I was looking for the data deletion link. What do you mean, no answer found? Data erasure. Okay, Ars Technica says Pentesters arrested for assessing courthouse security. Okay, let me take a look at the link. So the data erasure link doesn't exist. Okay, let me try that again. So this is going to be request data erasure. Sorry, I don't have... I'm a little bit busy right now, but can you tell me TLDR of what happened in the update? MND, thank you. So no answer found. So there's no data erasure endpoint. I don't know about this. Let me record it, and then we'll move on. It's supposed to be for erasing data. They got paid. Whoa, how many zeros is that? Is that 6 million? No, that's 600,000. $600,000 from the county? That's okay. $600,000. I mean, that's still a lot of that's a lot of money. Is it enough? That's hard to say. Okay, so 60,000, 600,000, 600,000, right? Okay, next. So your account, change password. Okay, so this is the change password endpoint. But the change password endpoint looks a bit it looks a bit weird up here. Let's try reloading the page. Okay, so your account, privacy security, change password. Why does the link look so weird? Proxy, HTTP history. Let's go down to the bottom. It's a lot of JSON information down there. That's a lot of JSON. Okay, so let's try that one more time. Account, change password. So this does let you change the password, but the thing is that... Oh, it's privacy security change password. Okay, let me copy that. For changing user password, the user's password. Okay, and so change the password. What else can we do? We can configure 2FA over here. So secure your account with an additional factor, scan into QR code with an authenticator app supporting TOTP. So for example, Google Authenticator to get started. Current password and initial token. Current password and initial token. Okay, let's record the endpoint here. So it's privacy security, two-factor authentication. For setting up 2FA. Okay, and next. Whoops. Privacy security 2FA last login IP. I wonder if this is some sort of security mechanism. So last login IP, this is not a regular feature in a lot of websites. It must be some sort of security mechanism to make sure that your account isn't being accessed from weird places. Displays the IP address of your last login. Okay. So last login IP, and we've got logout, orders and payment. We've taken a look at all this stuff already. Okay. There's the search link over here. Blocked illegal activity. What? What do you mean blocked illegal activity? We didn't do anything illegal, did we? Okay, that's a serious weird place. I don't know what IP address that's supposed to be. Cross-site scripting? I mean, I don't think I did any cross-site scripting here. Not too sure why they would have blocked our suspicious activity. Okay, so we'll just type in something. Test. You successfully solved the challenge. Expose metrics. Find the endpoint that serves user data to be scrapped by a popular monitoring system. I don't even know what this means. Loopback 127. So OWASP SSL Advanced Forensic Tool, OSAFT. I don't even know about this. So what is the name of this endpoint? That's search. So this is just the search endpoint. Q equals test. Q equals test, but I mean we can test it for like all sorts of different kinds of vulnerabilities and payloads. We can try SQL injection or anything else really. Something like a metric endpoint. So I think... No, there's actually more links over here. So in the side menu, we've got stuff like the GitHub repository, help getting started, and then we've got some other web pages such as customer feedback and complaints and support chat. So this one goes to customer feedback. Okay, the customer feedback also has a CAPTCHA. Oh, there's a CAPTCHA you have to answer to supply the feedback. Interesting. So what's this endpoint? This endpoint is called contact. This is the contact endpoint. Okay. This is customer feedback form. That search bar is asking for XSS. I suppose it really is. I mean, we could just give it a go right now. So search bar. What was it? We can put in some tags. So this is a bold tag. This is bold. This is not. And see if it goes through. Huh, nothing displays. So it looks like it's not, this isn't reflected back at us. Okay, so if it's not reflected back at us, I don't know. Oh, this worked. Okay, so this is probably vulnerable to XSS because we got the bold tags to work. So we can give ourselves like a script tags. So /script, and then put in alert XSS. Okay, and see if this works. Or equal 1 equals 1? I mean, one vulnerability at a time. This does seem to be pretty slow, though. Okay, try just to search to see what you're looking for. Carlin Slam, hello, nice to see you here. What is up? Okay, let's just ignore this for right now. So this is the customer feedback form. There are only a few endpoints left to look at. Let's take a look. So customer feedback, this is complaint. So make customer complaints for this one over here. You can also upload a file. So this is another thing that you should be paying attention to when you're doing security testing. Any endpoint that lets you upload a file could be used for abuse. And what's the name of this endpoint? Complain. Okay, let me copy that. Customer complaint form can upload files. The server is responding really slow. It certainly seems that way. It doesn't look like the cross-site scripting JavaScript activated, but I guess we can wait a little bit for that. So let's see, complaint support chat. This is which endpoint? Ah, so there's some sort of bot test. The interesting thing about this is that this application came out before the advent of like LLM chatbots. So it's not an LLM chatbot that's chatting with you here. Okay, Jan the man. Yo, who's hacking who here? Who is hacking who? That's a good question. But hello, nice to see you here. It's printed in plain text, so did not work. Didn't get your name. What should I call you? My name is the Shyhad. And I guess we're not getting a response here. But what's the endpoint? This endpoint is the chatbot endpoint. Yep, trying to have as much fun as we can. Okay, so this is the chatbot endpoint. Chat with the bot. Okay, there should be like a couple more. So there is About Us and then Photo Wall. About Us, corporate history. Okay. Check out our boring terms of use if you're interested in such stuff. FTP. This leads to an FTP endpoint. To an FTP folder. That is interesting. So, I mean, the legal stuff is here, but it's inside the FTP directory. Okay, what is the purpose of tracking all the endpoints in the website? Well, I mean, if you're able to keep track of endpoints in a website, that means that you can systematically test the endpoints one by one. So we also need to know what sections of the website exist. So we know that there's a registration endpoint, a search endpoint, privacy policy, basket, recycle, etc., all this stuff. If for some reason we ran out of stuff to test, we could go through each one of the endpoints and test them one by one to see if there's any vulnerabilities that we can enumerate there. Yeah, enumeration is what we're doing. But this is pretty standard. If you have a tester who's not going through everything methodically and systematically, that's a bad thing. Okay. So let's see, legal, what do they even call it? I have a question, does FTP have any vulnerability? FTP can have lots of vulnerabilities. Yeah. So this is called the legal information, okay? The legal info for the company. Okay, but more importantly, there's an FTP directory which we could potentially enumerate as well. So let's give this a try. So just try to directly navigate to the FTP directory. This is bad. This is very bad for the security of the application. FTP versus SFTP. So SFTP is secure FTP. It's the encrypted version of FTP. But FTP by itself is a pretty old and well-known protocol for sharing files. So I mean, we just found all these files that regular people shouldn't get access to. So that's pretty bad. SFTP. Oh, okay. That's FTPS. Hold on. SFTP, is that the SSH one? Let me look it up really quick. SFTP protocol. Oh, okay. This is the SSH file transfer protocol. So this is, it's a different one. All right, I think I understand. What OS are you running? So we're currently running Kali Linux. We're running a Kali Linux machine for security testing, but we're actually running on top of a Windows system. So the Kali Linux system is a virtual machine that we're using right now. But let's see. Let's keep on enumerating here. So the FTP directory, this is a general file repository that shouldn't be public. Okay. So we found this. Next. I mean, we could check out all of these different files here. Of course, what we should do first is we should just finish enumerating the site regularly. So we got our logout. We got our photo wall. So the photo wall. Pick image. Pick image. We can share photos. So this is another like file upload endpoint. Okay, FTP and FTPS should not be used these days. SFTP is fine. I mean, the thing is that all this old stuff, people aren't getting rid of it because it's because if it ain't broke, well, they don't think it's broke, so they're gonna keep on using it. So the photo wall is an endpoint where you can upload photos. So any place where you can potentially upload something is a potential security vulnerability. Telnet D had several CVEs. Okay, when you're doing this, do you go through all the endpoints or just the ones you can upload things on? I mean, we're supposed to methodically go through every endpoint that we can find. I think we're pretty close to finished with our initial walkthrough, so we'll be checking out new stuff in just a bit. But if you were doing this as a security assessment, you would definitely go through the application normally. Deluxe membership. Enjoy the amazing benefits of a deluxe OS Juice Shop. Okay, so there's a membership page, or there's a membership sign-up page. What's the name of this endpoint? This endpoint is called Deluxe Membership. And become a member leads you to Payment Deluxe. Okay, photo wall. This is deluxe membership page where you can pay for deluxe membership. Okay, you go through everything just in case it allows things it shouldn't. You do not check every page for everything though. I mean, this is, you might go through every page for everything if you run out of stuff to test. It's just normally what you would do is you do it like one passover to record all the stuff that you can find that regular users would be able to see, and you would focus in on what you think might be vulnerable, and you might make a second pass after you've run out of things that you were initially testing. Okay, and I think we're done with our initial pass. So about us, deluxe membership, help getting started, GitHub. I don't think these are super relevant. We are logged in, right? Yeah, we are logged in. Orders and payment, privacy and security, and I thought there was some sort of what is it called? Like a photo gallery that was on the photo wall. But the photo wall doesn't, oh, the photo wall doesn't load up yet, jeez. Okay, so the photo wall here has a bunch of vulnerabilities as well. So how does one find available endpoints of a site? Is that what spiders do? How do they work? So the spiders are trying to look for common endpoint names, and they're testing them on the web page to see if they respond with a, what is it called? With a valid response. So that's how they figure it out. So the photo wall here actually has a bunch of vulnerabilities on it as well. We'll take a look at this later. Maybe you can try GoBuster with the smaller word list. Yeah, maybe. So we pointed GoBuster at this, and apparently we sent too many requests. So the other thing that we might be able to take a look at is the robots.txt file, because we found one. Robots.txt. So yeah, if we didn't discover the FTP endpoint through other means, the robots.txt file points us at the FTP endpoint. So if we got the FTP endpoint, I think there was also like a security.txt file in here as well. Security.txt. Okay, so we've got hiring. There's also a jobs endpoint that we didn't know about. Okay, so localhost, well-known CSAF provider. What is CSAF? So there's also a scoreboard that we discovered through this. Mail to do not reply at oas-juice.shop. So there's a scoreboard endpoint, and then there's a jobs endpoint. Okay, so let's try... Let's put this in another tab. So we'll call this jobs. Jobs didn't lead anywhere. So hiring, jobs. Let's try that again. So the jobs endpoint doesn't exist. It just redirects us to something very generic looking. Unless there's something like hiding on the source. I don't think so. How about we try the scoreboard? Okay, so what do we have? Hacking challenges, coding challenges, challenges solved. So this is where we keep track of all the vulnerabilities we found. 17 challenges unavailable on Docker due to security concerns or technical incompatibility. So we found a bunch of different vulnerabilities here that they tell us about. So that's good. Let's keep track of this. So this is scoreboard. Keeps track of the vulns you found. Okay, we've got an ad running on Twitch right now. So when ads run on Twitch, we put on the birds. Okay, so we'll be back in about 60 seconds. I just need to take a little water break, but enjoy the birds, and we'll be back in just a little bit. Okay, so Dan plays live. Why are you frowning? We got a little squirrel over here, and let's go ahead and get back to the hacking. Okay, we got the scoreboard, and what else are we doing? Bully the chatbot. Bully the chatbot. Receive a coupon code from the support chatbot. Huh? We can get a coupon code from the reports from the support chatbot. That's funny. So we got. I mean, I think if you really wanted to learn about web app security flaws, you could spend a lot of time with the HackSmarter Juice Shop, and you could learn a lot about conducting these attacks. So like I said, if you want to check this out, you can check it out on Try Hack Me, or you can check it out on HackSmarter, which is what we're doing right now, over at this link. Okay, so we found all this stuff, and there's like a security.txt endpoint as well. And what does it tell us? So this is one thing I'm not really too sure about. I'm pretty sure like security.txt is a standard, but I'm not super sure about what is supposed to go in there. Security.txt file. Proposed standard for defining security policies. So it defines the standard to help organizations define the process for security researchers to disclose security vulnerabilities discreetly. An accepted standard for website security information that allows security researchers to report security vulnerabilities easily. Okay, so I mean it can also point people to parts of the website you might not want exposed. But I guess it's not all that bad here. Nothing like super important is exposed, as far as I know. Okay. Security.txt for responsible disclosure. And there's also the robots.txt, which points us to a insecure endpoint /FTP. All right, so I think what we should do is we should take a look at our fuzzing results. What's amazing of CSAF from security.txt file? That's a good question. It's not really something I'm super familiar with. CSAF. What was it? CSAF. What is CSAF? I'm guessing it's web security. What is CSAF? Web security. Okay, Common Security Advisory Framework is an international open standard machine-readable format for security advisories. So what is it? But isn't the cat and mouse game infinite? Well, I mean, cat and mouse games are supposed to be infinite. Well, I mean, most of the time they are. So CSAF is a language exchange security advisories. It plays a crucial role in cybersecurity arena. What is the purpose of CSAF? Allows stakeholders to automate the creation and consumption of security vulnerability information and remediation. So, I mean, I'm pretty sure we can't access this endpoint directly. It's localhost 3000. Localhost 3000, and we didn't find anything running on port 3000, as far as I know. Unless we can just navigate directly here. Yeah, there's nothing here. Whoa, what? No, there is something here. There is something here. That's funny. All right. So let's see. Juice Shop, namespace. And we got some open PGP keys. I don't know if we can use these though. Canonical URL. Okay, distributions. I mean, can we directly navigate to these directories? We can. We can directly navigate to this well-known directory, .wellknown. CSAF, and there's a bunch of files in here. Okay, let's record this endpoint. Funny, funny, funny. Okay. Contains a lot of files regarding CSAF. What does it stand for? Common Security Advisory Framework. Okay, so I mean, this kind of endpoint, they might have some secrets hidden in these kind of files over here, but the application's pretty. It seems like there's a lot of different parts of this website for sure, of the application. Well known with directory browsing. Well known with directory browsing. I wonder if this is... I wonder if this is common on like on word lists. Well known directory, sure. This goes back to regular Juice Shop? Yeah, this goes back to regular Juice Shop. Choose language. Oh, there's a language selection. Huh. So sometimes there are vulnerabilities in these kind of language selection endpoints as well. So if we could like select another language, I don't know. How about Deutsch? Language has been changed to Deutsch. Okay, reload the page. Does it? Oh, it does change over to German. Okay. And then we can change it back to English. Okay, and then we can take a look and see what happened in Burp Suite. So in Burp Suite, go down to the bottom. So there might have been some sort of application configuration. We have our bearer token. Wait. I guess changing the language of the application really didn't go through. Didn't go through like a GET request. Language has been changed to English. Go down. REST user, who am I? Did we send a post request in here? Did the cookie or the token change? That's a good question. Dan Plays Live says, what is Burp? So Burp is the security tool that I'm using right now. It's pretty much the standard security tool for web application security testing. And it's made by this company over here called PortSwigger. If you want to learn more about web application security testing, this is probably the place to do it. Did the cookie or the token change? That's a good question. So I would figure that changing the language would have, REST languages, okay. So get REST languages. And did we send something with this? Let's put this in the repeater. So in the repeater, we send something like this. And I think continue code equals this. Language equals en. So we do send some sort of token with the cookie language. So the cookie language is en. So set cookie. Yeah. So if we send this request, it sends us like 304 not modified. But we can change the language here. So it's changed the language to DE instead. And let's see if anything actually happens in the application here. So reset. So the language didn't change when we changed the name of the cookie there. Oh well. Okay, so what else should we start chasing down? I think we might want to take a look at some of these other endpoints. So GoBuster 1. We found a promotion endpoint. We also found some API endpoints. Well, I guess we can kind of ignore all of these 500s. /restaurant, because these came back 500, which is like server error. Okay, so we go to /restaurant. Unexpected path restaurant. And it basically does a stack dump. What were the other endpoints we wanted to check out? So maybe like metrics. Metrics. Yeah, let's check that one out. So /metrics. Okay. This does seem like a bunch of metrics. Juice Shop users' social interactions. Review, feedback, complaint. I guess this is just a bunch, yeah, metrics. So what else did we find? restricted.txt. FTP came back. Promotion came back. Robots.txt came back. Let's try the promotion endpoint. Promotion. We got a promotion video here. So promotion has an endpoint for a promotion video. I don't think there's anything else here. There's a back button. Let's try sending a curl request. Curl v this thing. Okay. So what were some of those other suspicious endpoints that we found? Robots.txt. There's a video endpoint. Assets. So there's an assets endpoint. Can we directly navigate to it? Okay, and then there's a video endpoint that we can take a look at as well. Video. The video endpoint doesn't lead anywhere. Video. But the response that we got from the video endpoint, according to GoBuster, was really big. So I'm not too sure why we don't see anything here. Was that a conversation? Sorry. What conversation are we talking about? So now it's not responding. Oh, this is the video here. Should we try downloading this? Let's try like curling it down. Was there a conversation in the source code? Oh, you mean this? OWASP is a community of developers, technologists, and evangelists. OWASP is a non-profit that stands for the Open Web Application Security Project, improving the security of software through tools and resources. I mean, I'm not too sure. This came back in the response for which page? This was the promotion endpoint. I'm going to see if I can download that video. So I'll try curling it down. Or like wget. So wget this thing. Okay, so this is an MP4 file. So this is a video file. Let's try opening up this video. This sure is a weird box. So exif-tool this video. So there's OWASP 3.mt4. Okay, untitled project. Let's try opening up the video. XDG open. Oh, interesting. Okay, so this is what I heard from the video. So the video was this dialogue right here. So OWASP is a community of developers, technologists, and evangelists improving the security of software, or something something. So I guess this is like subtitles or like a transcript of what they talk about in the video. All right. So what else? Security profile, security.txt, robots, promotion, FTP, security.txt. How big is the video file? The video file is like 9 megabytes. If you want, I can throw it into Wormhole for you if you want to take a look at it. Wormhole.app. So if you want to take a look at the video file yourself, here's the link. Okay, APIs dot promotion. All right, so I think it might be time to take a look at the FTP directory. So the FTP directory has a bunch of different stuff. So we got coupons 2023 md.pack. I wonder what this is. So only MD and PDF files are allowed. That's... I mean, we might be able to directly download this stuff in this directory. How can we do like a recursive download with wget? Let me look that up. wget recursive directory download. Mirror? Oh, okay. wget mirror? Mirroring a website with wget allows you to recreate a local copy for offline browsing or backup. So wget mirror, convert links, adjust extension, no parent. I mean, I think just mirror should be fine. Okay, so I'll make a separate directory for this. We'll call this the FTP directory. wget mirror, and then we'll get the FTP endpoint, which is over here. Okay. Let's see if it does it correctly. Looks like it might be copying. No, it's not letting me do it. Connection closed at this whatever over here. Okay, cancel out. Yeah, so we didn't manage to find anything. TP. You just index.html. So I guess we're gonna have to look through these one by one. So we got acquisitions.md, Easter eggs, Easter egg. So we can't download this. I mean, we can probably download this one at a time. Forbidden. So error 403 forbidden. Random weight? I'm not sure. I'm not sure what we should be doing here. So only .md and PDF files are allowed. So are these the only ones, the only file extensions we're allowed to download? Let's go back. So we got MD. So MD lets us look at this information. Announcement encrypted. What? Oh no, this looks like some sort of AR stuff. So these are just a series of numbers. I mean, let's select all. We can save as. Actually, let's just download this. Haha, hello, nice to see you here. Quarantine? I mean, we can probably look at the quarantine directory as well. So download this thing. Okay, so we're allowed to download it. And then we've got our quarantine directory over here. In the quarantine directory, we've got juicy malware macOS. Juicy malware macOS.url. Juicy malware, huh? Okay. So you got juicy malware Linux ARM 64.url, juicy malware Linux AMD, juicy malware Windows 64. Is this legitimate malware that's just sitting around in a directory? Can we download this? Juicy malware, everybody. Okay, they let us download it. What kind of file is it? This is ASCII text, so it's not. This is not code. What's with that name? With that name, unlikely. So it looks URL, huh? Juicy malware. Okay, so this is just a shortcut. Ah, okay. So github.com, Juice Shop, juicy malware raw master, juicy malware macOS 64. I mean, what happens if we navigate here? We get infected, everybody. We downloaded it. We downloaded the juicy malware. Great. Let's try moving it into our current directory. Okay, and what is this thing? Juicy malware macOS 64. This is a 64-bit x86-64 executable for Match O. So is this macOS executable? Just like Poppy always wanted, of course. All right. Juicy malware. You know what we could do? We could put this up on what is it called? Virus Total, and see if it's an actual virus. So where is it? VirusTotal.com, and we could try uploading this thing. Choose file. Where do we put it? HF FTP. Juicy malware macOS 64. Okay, open it up. And this is a, wow, it's a real virus. Everybody, it's a real virus. It gets, well, it doesn't get flagged by too many, actually. It only gets flagged by 24 out of 64 engines, antivirus engines. So I don't know what kind of malware this is supposed to be. Anyways, that's an interesting find. Nasty, nasty virus. All right, everybody. So the next thing we can check out is probably the encrypted announcement. So it's just a bunch of numbers. I mean, we might be able to throw this inside of, well, what was it? What is it called? CyberChef? These are just numbers, so just copy them all and then throw it into CyberChef. We can start manipulating it and see if we can find something. Okay, thank you for putting in effort to share videos, especially on a Friday. I'm really appreciate it. Respect you for stewardship of experience. Thank you. Thank you very much, Sevid. Thank you. Are we... We're not done yet. Okay, so copy all the numbers. Just a second, everybody. Done. Copy, and then put it into... Oh, CyberChef? CyberChef.io. Okay, paste in that input. And this is supposed to be... Is this going to be decimal? If these are just numbers, if these are just really long number strings... From decimal. So converts the data from an ordinal integer back into its original form. From decimal. Data is not a valid byte array, so this is not... So let's just say that there are no delimiters. Because there's no spaces here. Yeah, it's not, it doesn't like these. There are no spaces. So if we've got a really long, string of numbers, could be what? I'm not sure. So from decimal to decimal. What do we turn these long number strings into? Could still be hex. So, from hex. From hex. Okay, delimiter is no delimiter. Yeah, it doesn't like this stuff. So from hex dump, from hex content. Magic? I mean, I guess we could. From decimal, from hex. Let's get rid of the from decimal. Okay, so if we get rid of the from decimal, then the hex actually comes through. But, I mean, this looks like... What does it look like now? Soundtrack name, please. This is Void Stranger. So, search for this. Haha. So from hex, this is the auto, no delimiter, auto delimiter. So this is probably... No idea what the encryption could be here. So this is hexadecimal, and then we do something to it. This is not base64. From XOR. If we XOR it, I mean, we can try like an XOR brute force. XOR brute force doesn't seem to be giving us anything. Try the magic. Yeah, I think magic might be the way to do this. Okay, magic internal error in blog, too much recursion. So intensive mode, let's just get rid of the from hacks here and then let magic do its trick. And nothing really happens here. Try it in intensive mode. On the numbers directly. So magic on the numbers? Yeah, this is what we're doing right now. I mean, it's either... So this does... It looks like it's doing like an XOR directly. The interesting thing about everything in Juice Shop is that Juice Shop is very well documented. So if you wanted to know anything about Juice Shop, there's a lot of like good write-ups for it as well. So OWASP Juice Shop write-up. OWASP Juice Shop full walkthrough. There's official documentation as well, so the people who created the Juice Shop also have documentation for it. But anyways, let's go back. I don't think I'm gonna find anything here. I'm not much of a cryptographer. Where did we find these numbers? So these numbers were in a file called like encrypted announcement, I think. This is announcement encrypted.md. So we found this in the FTP directory over here. Yeah, over here. So coupons at md.back. Got package.json.back, suspicious errors.yaml. Package lock JSON, encrypted, encrypt.py. Oh, you know what? Maybe we should take a look at this. But we can't download this file because it says only MD and PDF files allowed. So we got acquisitions.md, GNI. No one else creates content like this. It's truly worth something. Worth following. Hey, thanks. The code that did the work. It might be the code that did the work, but I don't know if we can download this. So, I mean, we can't curl it down, I don't think. Curl? Yeah, so it gives us the error message, and we can't download it. So what about this acquisitions.md file? Planned acquisitions. This document is confidential, do not distribute. Our company plans to acquire several competitors within the next year. This will have a significant stock market impact, which we will elaborate with in detail in the following paragraph. Yup, so this is sensitive information. Let's go back. You know what? I'll demonstrate a couple of other vulnerabilities on Juice Shop as well. So one thing about the Juice Shop is that there's an SQL injection vulnerability here. Let me show you what it is. So over here we'll log out. Where's the logout button? So account logout. And then account login. And then here in the login page, we're going to put in our famous SQL injection payload. Quote, or 1 equals 1, and then quote out everything else, test for password, and then log in. So after we do that, dang, this application is slow. Okay, it looks like the hex showed up as how I see it. HTTP dumps on Wireshark, so it's HTTPS or TLS encrypted. TLS encrypted? I mean, if it's TLS encrypted, log in admin. Log in with the administrator's user account. So we were able to log in as the administrator by using the SQL login bypass payload. So if we take a look at who we are admin at juice.shop, juice-sh.op. So because we're this user account, I wonder if we've got extra access. Okay, so admin at Juice Shop, orders and payment, customer feedback. I don't see any extra like administrator functions in here. So login admin, login with the administrator's user account. Are there any details? Oh, maybe the administrator has like cards or something. So orders and payment. So maybe take a look at the saved addresses or the digital wallet. Okay, no digital wallet here. Saved addresses? No saved addresses here. User profile. So we got a profile name and we can upload. Interesting. We can upload upload files. So let's see, all image formats are accepted. This is a file upload endpoint, of course, which means we could potentially upload malicious files and maybe get direct access. That'd be nice. Okay, just let's give this a try. Let's try to upload a malicious file. Oh, okay. We're gonna do this for another 20 minutes, and then we're gonna wrap up the stream. Okay, let me set up my time. We'll move on into the last portion of the stream. Okay. Alright, so the last thing we're going to do is we're going to see if we can get a file upload vulnerability to work. I hate these kind of write-ups. Juice Shop, CTF encrypted stuff. Oh, Reddit. There's a write-up on Reddit? Kind of stumped with what I've got thus far and how to proceed. Got any ideas? Figured out how to decrypt it, but sadly it pertains to the flag I already got. Pertains to a flag that I already got. Juice Shop encrypted stuff. Well, I mean, I can take a look. They want me to prove my humanity. The jig is up. Okay. Oh, interesting. I'll take a look at this later, SysOS, thanks. Alright, so we're going to see if we can get file upload on this. So we're going to get a sample file. So maybe like a PNG. Okay, example PNG. I think we should look for like a 1x1 So example image 1.1.png. Here we go. Okay, and then we will copy it over to our current directory. Permission denied. Permission denied. Oh, that was move. Sorry, I wanted to do copy. Okay. Sick in the mind. Hey, what's up, man? We're just trying to see if we can get a file upload on Juice Shop over here. Because we love the Juice Shop. Where was I doing this? Okay, I was doing it from here. So we will upload our sample PNG file. It's got the juice. It does have the juice. So it's in temp. Okay. All right, select the thing, upload the picture, and so the thing about uploading files to try to get like remote code execution, web shells, and stuff like that is if we don't know where the file gets uploaded to, it's not really useful. But we'll see if we can locate it afterwards. We can also supply an image URL, and we can also set our username. Okay. Upload picture. Blocked illegal activity. Illegal activity? Wait, how is this illegal? Wait, how is this illegal? This is the intended way to use the application, isn't it? Maximum file size 150 kilobytes. All image formats are accepted. So, image file blocked illegal activity. Don't think that should be the case. Okay, let's go back. Profile. Which user are we acting as right now? So we are the admin. Okay, and we're gonna try to select a PNG file, and then we're gonna try to upload it. Does this work? The application doesn't seem very responsive. Let's see if anything else has been added to the GoBuster file. So the fuzzing and connection refused. Connection refused. robots.txt. I think GoBuster finished. So promotion endpoint, there's a robots.txt endpoint. There's a security.txt endpoint, metrics, redirect, FTP directory. And there's a video. So going to the assets directory redirects us to, where does it redirect us to? Oh, we managed to successfully upload the file. Okay. So it's good that we were able to, let's open the image in a new tab. Okay, so we got the uploads directory. So assets, public, images, uploads, 1.png. 1.png. How does it determine what to name the thing? How does it determine how to name the file? So if we go over to our Burp Suite proxy and we get the post request over to profile image file, put it in the repeater. Okay, so this is our PNG information right here. So name file, file name equals example image 1.png. Let's put this in, yeah, it's in the repeater now. Let's see if we can upload it with a different file name. So if we send this, what happens? Dang, this is not very responsive. Okay, so this redirects us to profile. But what happens if we decide to give it a different file name? So example1.php. Is this a PHP app? If it doesn't run PHP, then it's kind of useless to us. So what kind of technology is being used to run the application? I haven't gotten any indication that it's using PHP, so I mean, even if the application isn't PHP itself, it might still, the web server might still run PHP code. Who knows? Okay, let's see if we can directly navigate to the uploads directory. So the uploads directory doesn't give us anything. The images directory also probably doesn't give us anything. Okay, images directory gives us nothing. The public directory also gives us nothing. And the assets directory also gives us nothing. Okay, but what happened? What happens on our profile page? This is going to take a while to load up. Actually, so user profile is this. Let's open it in a new tab. So this is still a PNG. So this probably didn't get renamed to PHP. Let's see if we can double barrel this. So image1.php.png.php, and we'll try that. Send. So if it works, we'll try taking a look at our profile picture again. How about 1.php? Can I access that? This doesn't give us anything. I mean, if it was a PHP file, it wouldn't give us anything. What we'd need to do is we need to put in some sort of PHP payload. So let's make a PHP payload. So use something like payload, what was it, revshells.com? And what is our IP address? Our IP address is 10 this thing. Pandester TV says Wappalizer is a good browser extension to give some indication about the technology that the site uses. Let me take a look and see if it's... So Wappalizer isn't here, but you know what we could point at the website? We could point nuclei at it. Let's give it a shot over here. So nuclei. It's a -T, right? Not present. Remote template. Is it like U? Is it T or U? I don't remember. Is it like H? Okay, it is U. Okay, so we'll just wait for this to come back. But Pentester TV, hello, nice to see you here. What is up? So we'll just wait for this to come back, but in the meantime, we can... So this redirects us. I think what we want to do is we want to grab our IP address. Maybe we can get like a... Maybe we can get some sort of web shell. Yeah, web shell, web shell. We don't need to get a reverse shell right now. We just need to get a web shell. So let's see. PHP command small. This one. Which challenge are you on the Juice Shop? We're not on any particular challenge, but since I'm wrapping this up in just a little bit, I'm just going to see if I can get like a web shell or some sort of malicious file upload to get working. Okay, so PNG here. Let's delete everything. Insert our web shell. File name equals something. .png.php. See if it actually uploads. Send it off. Internal server, 500 internal server error. I wonder what caused that. We'll try resending it. So this is this does send an internal server error. Send. Yeah, illegal. Okay, error illegal file type. Error illegal file type. Okay, so that's what the error is all about. So illegal file type, how does it know? Okay, so let's try just getting back the original contents. So this is the original contents. It's still called png.php. If we send this, blocked illegal activity by this. Okay, so here, this is probably some sort of web application firewall. File endings of MindPipe. File endings of MindPipe, maybe. Let's try sending it again. Internal server error, blocked illegal activity. So we probably got pinged by the web application firewall when we tried to upload that that PHP file. So we might have to wait for a little bit before we can start sending malicious payloads again. Yeah. All right. So we got our OS Juice Shop. This is our user profile picture here. Now, what's one last thing we could take a look at? Maybe we could take a look at more like cross-site scripting payloads. So let's just get like your basic cross-site scripting payload. So it's going to be something like script /script alert XSS. Okay, and we'll try pasting this into the search bar. Okay, maybe a /0 encoding error in file names. Yeah, not exactly sure. I'm not sure if this is a working exploit on Juice Shop itself. It's just something I wanted to test out. Okay, so the Juice Shop is here. Let's try it here. Okay, did it send anything back? Doesn't look like it. So let's go back to the search endpoint first. Dang, this server is really unresponsive. Oh, we're not logged in. Huh. Okay, let's log in as HackerFrogs at likeandsubscribe.com. Okay, do we get logged in? Nope. Did the server crash? Target from list found as unresponsive 30 times. Unresponsive. Let's try pinging the thing. Ping 4. Okay, server's up. I don't know why it's being so unresponsive. So this is where we're logged in as the administrator. Here we're not logged in. Yeah, not logged in. Let's go back to the landing page. It's clearly JavaScript. Logo also reveals it. Yeah. I mean, I think they talk about the technologies down here. So we've got a bunch of different icons. This is probably their stack. Okay, let's try our cross-site scripting payload. Where did I put it? Let's just make the thing again. Script, alert, XSS. Okay, this didn't reflect back to us. Okay. Sad. Alright everybody, let's take a look at what's going on info6streams.com. This is just me. Alright. So, I need to get going, because, well, I need to refuel and get some sleep eventually. But who's online right now? It looks like... It looks like Moohiddles is on, so let's go ahead and raid into her channel. So she's usually talking a lot about like NASA stuff. I'm sure she's very excited these days because of the whole Artemis 2 thing. Let's take a look at what she's doing. Okay, here's Twitch. She is talking about NASA stuff. Alright, and the stream title is Artemis 2 News Conference Video. I'm sure she has a lot to talk about. Let's go ahead and start that raid. Thank you very much, everybody, for coming by, and hope you learned a thing or two. I certainly did. Alright, so when you arrive on Moohiddle's stream, if you give this message over here, I would really appreciate it. So it's OS Frog, Hip Hop Hack, OS Frog, just like this. All right, so everybody, are you ready to raid? We'll be back on Monday. Sorry, we'll be back on Wednesday. Hope everybody has a great weekend. But yeah, see you next time. Have a great weekend. HackerFrogs out in 5, 4, 3, 2, 1. See you next time, everybody.